12:30. So then we have a great group here. Let me give a quick introduction. First of all, this is called the Bourne Symposium. It turns out that you're sitting in the Bourne's facility. And the reason that both of those are named after Harold W. Bourne Jr. is because he's the founding director of the Institute. He's the reason that we're all here and that we have survived as an institute for 52, 53 years now. The actual Bourne Symposium has been going on for how many years, George?
31.
31. And it was originally had a different name, but it was changed for various reasons and made Bourne Symposium. We lost Hal during COVID, not from COVID, but he had a long, very fruitful career, so he would be very happy if he were here with us. So the other important thing about Hal is that when in starting this institute with others, his vision was based on going around to the National Academy of Sciences, many of the universities, to find out how you actually develop an institute that can have not just a long life, which we have had and will continue to have, but also do something that is different. And at that time, being an interdisciplinary unit was actually quite different. The terminology for interdisciplinary became very popular probably as about 20 years ago. And I can tell you that the concept of being interdisciplinary in university is a non-trivial concept. Universities are primarily based on separate disciplines, and there are various academic, financial reasons, political reasons for not necessarily interacting, even though faculty and graduate students do interact. So we are, for this university and for many universities, one of the oldest interdisciplinary units in the country, if not in the world. When we think about climate, we think about physical, chemical, biological, social aspects of climate. And if you really begin to dive deeply into what physical or social means, you find that there are a whole series of new directions that have emerged because of the fact that climate change has become such an important such an important reality. And it's only going to get bigger and bigger. And the way in which it will get bigger is by continuing to be very interdisciplinary. So it's important to remember that term because that's exactly what we try to do with this event, which is the very most important event for the Institute of the entire year. It's the time when we get to hear AGU like American Geophysical Union like 10-minute long, couple of minutes of questions, presentations by all of the graduate students and others who are interested in being involved. It's really important for us to be at as many of these presentations as possible. I know that some people have classes, you have to leave, but it's important to do this because of the fact that we need to understand what each of us does. And despite the fact that I direct this institute, I have no clue about what every single person does here. I think perhaps I certainly understand in my small little disciplinary world what we do, and I have an understanding of what others do, but it's primarily from coming to the Bourne Symposium and from reading the abstracts and the mini papers and obviously meeting each other whenever we can. So again, this is a really important event. It's our premier event of the year. It's the most exciting event of the year for us. And every single year, we have never been disappointed in the quality of the presentations and what we learn. I don't know how most of you think about listening to a presentation, but my particular view of a presentation is not just understanding what that person is talking about, but also trying to think about how what I do or others that I'm associated with might either interact with it, with that activity or learn from that activity. So I can't stress any more than that how important interdisciplinary and group participation is to the Institute and the importance of it needed. So there's one thing that is even more important than interdisciplinary, and that's people. We have graduate students, some undergraduate students, faculty and staff. And we certainly have a very, we have a staff that's probably unsurpassed in terms of its involvement with us and with the rest of the university. So the graduate students have gotten together and they would like to say something about two very special people. I'll get out of the way. And then we'll hear from Vince and like after that. Good. Big event.
Okay, I will be very short. When we started planning, we call this B and B surprise, and all the students, everybody was so happy to contribute, and yeah, and I saw so many smiles and so many great emails about them. And BB means Betty and Becky, and you are so meaningful. We really appreciate your being here around us. And this is a really small gift from all the CTI students for you to just and say we are really valuable and we really appreciating your being around us all the time. So please, and also I want to say that Alessandro's dad is not really coming to Maine. That was little lie. So we wanted you to enjoy your favorite restaurant around Maine, and this is please come and present your gifts.
Thank you.
I think everybody understands that this is what it is about that. Becky, these are the people that, I mean, unbelievable. You can contact 24/7. I'm not suggesting this, but they will take care of all of your problems. They've protected us in many ways. The university, they make sure that everybody can be connected, and it's tell you, having been the director for quite a while, working with Betty and Becky, it's a remarkable experience. Unbelievably professional, as we all know. No matter what you come to them with, no matter how annoyed one might be, they are always super professional and always ready to help. So we're very fortunate. See you from here. Dan Sanowitz, thank you.
All right, I just want to also congratulate Betty and Becky and say we wouldn't have this or any of the other events we do without them. They do all the work. And they know how to do it, and they make it work so well. They're caring and dedicated and competent beyond belief. But it's true. I couldn't believe it, because I've seen it year after year. All right, so we have our session beginning now. You have, if you're a speaker, you have 10 minutes to speak. When you get to 10 minutes, if you don't stop, you are going to see the clam up. I think, Elizabeth, you have the clam up there to show people what that looks like if you haven't seen it. Okay, and you must stop. If you do not stop essentially immediately, then you're going to get from me the backup clam up. And if you see that, just that's it, you're done. You get about a minute for questions while we're transferring while the organizer, or the moderator rather, is transferring to the next slide. So please, if you have a question, say it fairly briefly. If you have an answer, be fairly brief with that too. There'll be plenty of time in the various breaks to carry on discussions further. Elizabeth, all yours.
Yeah, well, yeah, Zoom's still open. Which one just bring the screen? Share the screen. So then we can share the screen. And yeah. There we go. Okay. All right, first today we have Emily Blackwood who is telling us about digitizing archaeological records, preservation, or cultural theft.
All right, so hi, as Elizabeth said, I am Emily Blackwood. I am an interdisciplinary PhD candidate. And today I'm going to be talking about some of the ethical aspects that I think should be considered when utilizing digitization technologies in archaeological research. So archaeology is the study of the human past through the material record that is left behind. And this presentation expresses my own views and opinions formed over 12 years of archaeological training and practice. So cultural material refers to any individual object or groups of associated objects that have been recovered from archaeological contexts. I've been trying to use this, as opposed to the term artifact, as an attempt to return and associate human agency to these objects. Language is important, but often is an overlooked detail of discourse and research. The term artifact implies an object that has been modified by humans in general. The term cultural material implies the objects hold cultural agency to a specific group. While it may seem shocking to some in this room, it is not standard practice to ask permission from or consult with Indigenous or descendant community members on archaeological research that is conducted on private land. There are laws regulating federal, state, and tribal lands, but it's also not standard to ask what is published from this research in site reports, photographs, it's used in presentation materials, repositories, websites, etc. These decisions are mainly left up to the researchers. And once data is added to and visible in the public domain, it's exceptionally difficult to control how it's used. Professional societies and associations have established principles and codes of ethics relating to best practices and standards, but there are no guidelines for archaeologists to use when creating digital collections. Intellectual property refers to inventions, literary and artistic works, designs, symbols, names, things that are used in commerce. Cultural intellectual property is a concept that is acknowledged, but it's not enforced, and it leads to a lot of cultural theft. Digital assets are digital copies of a physical object. On the right is a 3D model of my trowel that I use for excavation. With respect to digital curation, language such as digital asset is used to specifically separate a digital object from its physical object form, making it subject to new ownership, IP, and copyright. If something is considered a new object, permission isn't needed for how it's used. Ultimately, ownership of a digital asset falls to the creator of the asset. This is why digital management plans and user agreements are so crucial, yet often overlooked. In the United States, the vast majority of archaeologically recovered cultural material is not owned by the indigenous communities whose ancestors created them. Instead, they are owned, stored, and curated by universities, museums, and private collectors, sometimes with curation agreements, often not. This really limits access and control over indigenous cultural heritage to the specialists. Digital data may become obsolete if it isn't updated to the newest version of software or a compatible alternative. Additionally, it should be viewed as unethical to create a digital repository if budgeting does not exist for its ongoing upkeep. Digital curators and archaeologists need to be especially cautious when digitizing cultural material and should be having ongoing discussions with communities whose heritage is being digitized. Informed consent should be obtained and user agreements established before any digital asset is created. If not brought up by the communities, it should be the responsibility of the archaeologist to do so, as perceived power differentials between archaeologists and community members may be preventing them from asking. Or they may not be aware of the specifics of the licensing agreements and the terms of service for the apps that are being used to create these assets. How many of you have ever read your entire licensing terms of service agreements for the apps that you use? In doing so, this allows communities to regain some control of their heritage, add their voices to an asset's narrative, and establish safeguards to protect sensitive data from being publicly accessed and abused. In other words, a conceptual reframing across disciplines of who the institutions that store these cultural materials serve would better help balance power differentials. I think something that a lot of us forget is that archaeology is a service. And we get caught up in the excitement of discovery and the potentials of new technology. LiDAR and photogrammetry, both of which I use in my own work, are amazing, and they have really taken the field to new levels, but we need to dig deeper into the ethical considerations when using them. Ethical archaeological research is collaboratively designed. The researcher's focus is aligned with the interests of the community. Methods of excavation and analysis techniques are discussed and agreed upon, and dissemination of information is verified before being made publicly available. Christina Douglas, Sonia Adelaide, and our own Bonnie Newsom are a few of the women who are really leading this charge. Access to cultural heritage stored by public and private institutions by Indigenous and descendant community members can be made unnecessarily difficult. It's often easier for archaeologists to access these data than it is for those communities because it's for research purposes rather than cultural. Value is given and associated with research, not to culture. However, decolonization efforts of the Abbey Museum here in Bar Harbor provide a local example of community collaboration to curate archaeology and culture as an interconnected concept. Being intentional with language can have powerful impacts and shift archaeological discourse to be more inclusive. Using Indigenous preferred terminology such as shell heap versus shell midden fosters agency, respect, and is a stepping stone towards trust. It also provides a non-Eurocentric perspective to the narratives and definitions of cultural material. Indigenous views of place and how and why space is and was used can vary greatly from those presented by archaeologists. Incorporating Indigenous naming conventions for people, spaces, and cultural material into archaeological discourse is a way researchers can support and advocate for inclusivity and restore human agency to material objects. It can be uncomfortable for some to learn that most objects on display or curated by museums were acquired through unethical practices, including pervasive and encouraged looting of sites, purchasing from unregulated antiquities markets, and not verifying ownership histories when accepting donations. These actions perpetuate new harms when those objects are turned into digital assets without consultation and/or are copyrighted to the institution. As much as archaeology is an extractive process, it also provides invaluable knowledge into our human existence. Digitization of this record can be beneficial to everyone involved if it's done with intentional care, under an inclusive lens, and not in the name of science. It allows for a reconnection with and a preservation of culture. Phones, tablets, computers, virtual reality headsets create accessibility to cultural materials that are housed or curated at universities, museums, in private collections, etc. The top two videos here reflect 3D models of two pieces of a broken bird bone flute from a site here in Maine. The bottom two images reflect these two pieces digitally stitched back together. The red boxes indicate where the break is. This can then be 3D printed together as one piece or individually as two pieces and handled with much less risk to damage. 3D models can be used in lectures, they can be shared, they can be printed, they are detailed enough to zoom in on. All of this allows for a more hands-on learning experience, but without the risk of damage to cultural materials. They can be curated as teaching collections that extend beyond what is housed by each individual university. And here in the top right is a video of a test unit from the Bears Den excavation this past summer that took place at the location of the old pump house here at UMaine. Bananas used to hibernate here in the winter when our mascot was a live black bear. It also creates opportunities for public outreach by allowing the public to learn about these spaces or materials without compromising a site's integrity, or digging them up themselves, which is what we refer to as looting. Google has an arts and culture platform that is working to do so, and you can see this on the right. With that, I would just like to thank my committee members, extend a gracious thank you to Bonnie Newsom for trusting me to create a digital collection, with some of the cultural heritage from Maine, and a special thanks to Roisin Rumsey, who was able to digitally stitch that bird bone back together. Questions?
Not really a question, but a suggestion. As you know, the National NAGPRA office promulgated new regulations. They don't even address 2D images. You need to talk to them about this.
Okay.
Seriously.
That's the list.
But yes, I mean, that's, the regulations are how you make this actually happen,
Yes, and right now there are none.
and they can do that.
Anyone else? I don't recommend wearing a jacket up here, it's quite warm. Thank you.
He's starting already.
All right, sorry about the technical difficulties. Next up, we have Amanda Gavin, who's going to present on the reconstruction of lake level in South Greenland using fossil diatoms and a three-dimensional bathymetry model.
Thanks. Hi, everyone. I'm Amanda Gavin. I'm in Jasmine Saros's lab, and today I'm going to talk to you about using fossil diatoms and three-dimensional bathymetry models to reconstruct lake level. And for this, we're going to travel down to South Greenland, which is the first known place of agriculture in the Arctic. It's south of the Arctic Circle, and this work takes place in the Qasiarsuk settlement, which is outlined in blue here. It's within the UNESCO World Heritage Site. Because this area is relatively high up in the fjords and has lower geographical relief, summers are mild and surprisingly have somewhat amenable conditions for agriculture. This area was originally settled by the Norse in the 8th century. Eric the Red actually lived right in Qasiarsuk. The Norse brought sheep, they plowed the tundra, they planted grass and created farming communities. Around the 15th century, the Norse settlements disappeared, so it either got too cool due to the Little Ice Age. There's hypotheses about social tension, diet shifted to marine mammals, and there's newer hypotheses from paleo lake climate reconstructions that the hydroclimate might have been shifting and drier conditions could have impacted hayfields. And so if we move to present day South Greenland, the Inuit sheep farmers resettled this area in the 18th century. Here there's sheep all across the landscape. There are hay fields. Lakes are abundant across the landscape. They're used for drinking water for humans and grazing animals. They are irrigated for hay fields. And some lakes even provide hydropower.
Oh, I apologize. That's because I'm in Zoom. There we go.
Okay. Still not working. Cool. And so the hypothesis that the Norse settlement may have collapsed due to a shifting hydroclimate is relevant to the challenges that present day Inuit sheep farmers are facing with climate change. If we look at the instrumental record from 1960 to 2020 or 2023 for summer precipitation, it overall is decreasing. There's a significant break point around 2008. And if we look at summer mean air temperature, the trends are that there's increasing air temperature from 1960 to 2023 with a similar change in slope around the late 1990s. And this time period is in line with the abrupt climate change event that's happening in Greenland and points to overall warmer and drier conditions for sheep farmers in South Greenland. And in tandem with warmer and drier conditions, we're seeing an increase in extreme weather events. This is a large rainstorm that happened in September 2022 associated with Hurricane Fiona, which also was along the coast of Maine. It wiped out a lot of infrastructure, caused massive flooding.
And then in November 2023, there was a big snowstorm. Over a meter of snow fell in early November when the sheep were still out to pasture. And then drought is also a concern. From 2008 to 2020, 6 years have been drought conditions that were significant enough to decrease hay yields and to require farmers to need to use irrigation. This is a photo of July 2019, which is when the NRT faculty did some scoping in South Greenland and talked to sheep farmers who shared that they had to kind of scramble to pull together their supplies for irrigation. And you can compare this to July 2020, where irrigation wasn't needed at all that summer, and the hay fields look greener. So it's certainly, drought has been a strain on farming operations. And so because lakes are important cultural resource across the landscape, and they also may provide an integrated signal of shifting hydroclimate over time, I'm interested in asking, how does lake level respond to interannual changes in weather and also the abrupt climate change event in South Greenland? And so to get at this, I'll use different methods to look at the different drivers at different time scales. For historical trends, I will integrate indigenous knowledge with the paleo reconstructions. For more present day lake level monitoring, I deployed 4 water level loggers that are collecting high frequency water level data. And from that, we can look at what are the interannual and seasonal drivers of water level. And then to look towards the future, we can use all of the information that I'll get from these parts and what we already know about the NAO and how that relates to summer precipitation to think about what we might expect in the future. And so for today, I'm just going to talk through some of the methods for the paleo reconstructions. I collected 3 sediment cores from 3 lakes in South Greenland. And in each subsection of the core, I can do counts of the relative abundance of planktic and benthic diatoms. And so planktic diatoms are generally in the open water in the photic zone, and then benthic diatoms are living along the shore there or along the shore, and also in shallow regions where light can still penetrate. They're attached to the lake bottom. And what I can do is get a count of the ratio of planktic to benthic diatoms, and that gives you a sense of what's actually the available habitat. And so a kind of simplified hypothesis that's often in the literature is that a decreasing planktic to benthic ratio of diatoms corresponds to a decrease in water level. The idea is that as the lake gets shallower, as the water level is dropping, the lake is shallower and light is able to reach more of the bottom and creating more benthic habitat. And then you might expect the inverse, where increasing water level would increase planktic habitat. But that's probably not what's going to happen. And so I am using a method developed by Jeffrey Stone to incorporate 3-dimensional bathymetry modeling that we can use to constrain what we're seeing with the diatom counts in the core. And so to do that, I interpolate these bathymetry maps from field depth soundings that were taken in the lake. And then I've been using this really nifty program called Surfer. And I can get a 3-dimensional model of the lake. And then I can systematically change the elevation of the lake level and calculate what is the available planktic to benthic diatom habitat at different lake levels. So for example, if this 0 is present day lake level, I can calculate planar surface area, basin surface area, volume, and then look at what might a P to B ratio be here. And then I keep lowering the lake level and recalculating that. This is kind of crude because I actually do it every half meter, so about 40 times instead of just a couple. And I've done that for 3 lakes in South Greenland.
these lakes all have different types of bathymetry. The top one is like clover shaped with a fair bit of shallow benthic habitat. This is like a deep lake with deep drop offs, pretty like bathtubby, and then the bottom lake has pretty complex bathymetry where it actually would separate into two basins if the water level dropped low enough. And I'll just walk you through one example. So for this lake, we have the planktic to benthic ratio on the top x-axis and depth on the y-axis, decreasing levels. And then I do the model at different light levels within the lake. So 2 meters of light, which is in this red line, that means light is penetrating 2 meters deep into the water surface. It would be a pretty murky lake. 5 meters is what the present day light penetration is in this lake. And then 10 meters is certainly not uncommon in South Greenland or in Maine. That would be a pretty clear lake. And you can see that the planktic to benthic ratio with a first drop in water level, it's actually increasing to more planktic habitat, which is the opposite of what the kind of simplified hypothesis might suggest. And then dropping below 5 meters, increasing benthic habitat. And also it's different for different light levels of light. There's more dynamic changes when a lake is darker, and yeah, less dynamic changes when there's more light. And so to wrap up, you can see it's dynamic, and considering bathymetry is important. And I'll compare that to the diatoms in the pore to better constrain the whole picture. Thank you.
Do we have any questions for Amanda?
Yeah, is bioturbation an issue, and what's the temporal resolution in the floor?
So bioturbation could be an issue. There's a couple different models that I didn't totally go into, but you can account for whether the diatoms are this or like resuspended throughout the water column. So that can be addressed. The resolution of the pores are 1/4 centimeters.
Temporal resolution,
Oh, I don't know yet. I haven't dated it.
okay,
Yeah, but I would expect, I want to look at a couple hundred years, which should be available.
thank you.
Yeah.
All right, thanks,
you.
Amanda. All right, next we have Eric Brown, who will be talking about a comparison of cellular thermoregulatory traits.
Thank you. So, maybe be the only mammal person today, which,
I think we're all members.
well, not today, you're not. Only these guys up here. So, as we might all be mammals, we are all endotherms, and as endotherms, there's this spectrum of bins that we kind of fall into, not us specifically, because we're all humans, but endotherms generally span the spectrum of, homeothermy, which is the strict control and regulation of body temperature and metabolic rate. And then it goes through this span of heterothermy, which is just degrees of difference in degree of control of metabolic rate and body temperature. And this flexibility in control of body temperature and metabolic rate is important because there exists this kind of flexible, at least species specific range over, a span of ambient temperatures where an individual doesn't need to spend any extra energy to elevate its body temperature. It doesn't need to spend any water to make sure it's cooled down to its ideal body temperatures. We call this the thermoneutral zone right here, which has some other contingent necessities attached to it, but it's important to consider the zone, the size of it kind of determines how much energy an individual is devoting to maintaining its body temperature and its metabolic rate. And because this is relying on ambient temperature, the environment is obviously a huge factor in determining, the size of this thermoneutral zone and how much energy is being devoted to maintaining a certain body temperature. And, this is seen in small mammals to large mammals, even though large mammals to a certain degree have this thing called thermal inertia, just because their body size is so large that in large part they can maintain a body temperature that's fairly consistent just because they're so huge. And beyond that variation, just in flexibility of control of body temperature and metabolic rate, there's also this variation that we see across mammals in the level of endothermy. And this is not a concrete phenomenon. This is a hypothesis for how we might bin these different levels of body temperature in mammals. We've got super endothermy and mesoendothermy and basoendothermy. And Barry Lovegrove proposed that basoendothermy is this ancestral state where, body temperature is more reliant on the environment because, this is a Cenozoic when mammals are really just coming into their own as, a clade. So over time through the Cenozoic, we get these different levels of endothermy that are more based on the animal's ability to produce heat on its own. And so the question is that, we have all these different bins of different kinds of endothermy at different levels. And so today we see all these different sorts. And if one bin we say is more ancestral, why do we see that around today? And to what degree are the ones that exist today, just holdovers from cat phenotypes, and which ones are, more derived basal looking type of phenotypes? And I hold that squirrels are the perfect group to look at this phenomenon in because they are everywhere in the world, almost. Those of you who have been to Antarctica, please let me know if you've seen any down there. Probably not, unless you brought it with you. But they also show like all these different phenotypes that we see in endotherms between, strict control of body temperature, metabolic rate, to hibernation. So, extreme like degrees of just allowing the environment to kind of dictate what the internal body temperature is. And squirrels are also very plentiful. We only have, several species here, but in the world, they are the second most speciose mammal family. And that's a lot to play with. And getting back to Barry Lovegrove's model here, squirrels pop up at like end of the Eocene, like 37 million years ago. So that gives us a lot of, evolutionary background to play with. And in that time, we see, squirrels diversify into all these different endothermic phenotypes. And so using these different trait databases and phylogenies and different data about mammals with squirrels as a focus, I created this phylogeny that kind of takes some of the more key endothermic traits, and this one is body temperature, and looks at how we might expect that to change through the available data for squirrels. And here we've got, and note that obviously there aren't 300 species here, so there's a lot of data we have yet to collect. But what we would see in blue of like a lower like normal body temperature, and like red is a higher normal body temperature. And these kind of denoting whether or not these species are known to engage in hibernation or other forms of heterothermy, such as torpor, which is just, kind of a shorter period of suppressed metabolism. There really isn't yet any, like, body temperature doesn't necessarily predict whether or not the species will hibernate or engage in torpor and vice versa. And we'll get into that in a sec, but we have a few species where they kind of just don't go along with what we might expect for a particular clade. And so some of the questions that we have then are like, what are the differences between these species genetically? And what kind of mechanisms, genetically or otherwise, would drive certain plates towards flexibility in these traits, or a tighter precision of control in these traits. And when did that happen? And for some of these species that they kind of grouped in with these hibernators, why do some just seem to not do that at all? And what would motivate them to do that? So here's just a couple examples. And so when we go back to this model, we also see that existing species fall in these different bins as far as like level of endothermy. So we have some that fall into this like more ancestral kind of phenotype of like lower normal body temperatures, and some like much higher. And it's also true that this isn't necessarily exclusive, and an individual might fall into multiple categories throughout its life or throughout the season or change of seasons. And so looking at metabolic rate as well as like a key endothermic trait, we see a similar trend where lower metabolic rates doesn't necessarily let us know whether or not a species is going to be more precise or loose with its control of metabolism or body temperature or metabolic rate. And so again, this is just for species that we have data for. We're very low on the data that's available. And so one thing we have to consider is in the environments that we see these animals in, how many are in environments where they just would never experience the environmental conditions that would allow for torpor or hibernation. And and how many do we see that if we put it in a cold box might take a very long nap, but not a permanent nap. And so, and given this long evolutionary history, what makes squirrels unique in that they managed to emerge from a tropical like North America of the late Eocene, but Scandentia tree shrews, which has been around since the mid Eocene, maybe like 40 some million years, they are still to this day exclusive to Southeast Asia and India, and only like 20 species. Same period of time, they fill a very similar ecological niche. What makes squirrels so special? And ancestrally, we know much of mammalia is capable of torpor and hibernation, so probably many other squirrels are as well. But as far as genomic data and looking at the mechanisms for why this is so, we're still we have a long way to go. And with that, I want to thank everybody who's helped me in the field so far. Climate Change Institute for allowing me to share my work. And with that, I just want to thank my subjects as well. And that's all. Thank you.
Do we have any questions, Aaron?
So I have a question about the two graphs that you used to describe endothermy.
Sure.
In the one that delineated the three types, it indicated that basal endothermy was the first kind of type as we moved across time, and then we grew into the other types.
Sure.
But in the phylogenetic tree, a lot of the basal endothermy seemed like it was a relatively new evolutionary characteristic.
Yeah.
So is it old? Is it new? What are we looking at there?
That's one of the questions we look forward to answering. I mean, that's the thing, it's like ancestrally we came from this like basal-endothermic condition, but now like why is it that it's still like beneficial to do that? And part of like being so flexible is that it's incredibly expensive to be an endotherm. Like it takes a lot of energy and water to like maintain a certain range of body temperatures. So like that's part of the big question is like why the hell would you continue to do that if it's so expensive, and like all these other animals have been around for a long time without having to like spend so much energy doing that thing. But yeah, not sure.
All right, thank you very much. Next, we have Ana Cueva, talking about a presentation, the unprecedented worldwide weather extremes since early 2022 have an association with the Hunga Tonga Hunga Ha'apai eruption.
Hello, my name is Anna Treva, and I'm a master's student in the Veterinary and Climate Studies program. And I'm going to talk about my thesis, which is on the possible connection between the Tonga Tonga Ha'apai eruption and recent weather extremes.
Oops, sorry.
Here we go. So just brief presentation outlines. I'll give you a little bit of background to the eruption and the climate. And I'll discuss my hypothesis and the motivation for this project, then go through the methods and some of my results which are in progress, and then the next steps to completing this project. So according to the National Center for Environmental Information, 2023 was the warmest year on record. It is 1.2 degrees Celsius above the 20th century average and 0.2 degrees Celsius warmer than the previous record, which was set in 2016. There were numerous extreme weather events that contributed to this really warm year. And there were also numerous extreme, climatologically extreme rather than like thunderstorms, which are also typically called extreme. But numerous extreme weather events in the previous year. Most literature, when discussing these events, primarily attributes them to anthropogenic climate change and the El Nino that emerged in 2023. While these certainly played a role in creating these extreme events, the climate models could not predict just how extreme the weather was in July of 2023, which is one of the main events that contributed to that, the really warm year. So one possible explanation for these for the really warm weather is that there is another factor amplifying the El Nino. That would be the Tonga Tonga Hunga Ha'apai eruption, which I will be referring to as Tonga for the rest of this presentation. It, as you can see in the bottom figure, the volcano is located roughly 3,000 kilometers west of Australia and 2,000 kilometers north of New Zealand. What you can see from this figure is that it is also located about 500 meters below the sea surface. And so the volcano, it began to erupt on December 20th in 2021, and it continued to erupt through January 15th of the next year. It is, according to the Smithsonian volcanism program, it has a volcanic explosivity index of 5, which is similar in magnitude to Mount Pinatubo, which erupted in 1990, and Krakatoa, which erupted in 1883. It is the largest eruption since Krakatoa. The eruption was heard as far away as Alaska, and it caused tsunamis across the globe. It injected material 55 to 58 kilometers into the atmosphere, which would be the lower mesosphere. Among that material was 0.5 teragrams of sulfur dioxide and 146 kilograms of water vapor. Yeah. So just to give you a little reference from what we typically expect of the climate effects of a volcano. Usually, the primary forcing is from sulfate from the emissions of sulfur dioxide. And so the sulfur dioxide uses a sulfate aerosol cloud that generally concentrates around the lower latitudes, and it reflects. It has a high albedo, so it reflects a lot of light. It cools the troposphere and warms the stratosphere. And because it warms the stratosphere, you get a steepened forward temperature gradient, which thus also increases the pressure gradient between the tropics and the pole. And this in turn strengthens the winds, which causes further cooling, which is also projected onto the North Atlantic Oscillation, which you can see in this figure on the bottom right. The figure on the left shows, again, the North Atlantic Oscillation and its, and the correlation between that and sea surface pressure. And so when it is in the negative phase, there's a less steep pressure gradient, and it's attributed to the negative phase of the North Atlantic Oscillation. Tonga is different from what we normally expect because the primary forcing for the volcano is water vapor rather than the sulfate aerosols. And so because of this, we expect to see the opposite effect of what we saw from Pinatubo or Krakatoa. Volcanoes are a primary driver of natural variability of the climate system. The water vapor is unprecedented. Current, and because of this, we don't really know the effects of the complete effects of what the volcano is going to do to the climate. Current research primarily focuses on the aerosol cloud, which has very little, or the direct radiative impact of the water vapor, which, however, the dynamic effects of the volcano are currently unknown or not very well understood. And so my hypothesis is that excess water vapor in the stratosphere from the eruption weakened the polar gradient and the wind circulation, and this provides a feedback to the El Nino, where it amplified the El Nino and lead to the extremes in 2023. And it would also, we expect to see it projected onto the negative phase of the North Atlantic Oscillation. So a little bit of my methods. I'm examining reanalysis maps using the ERA5 reanalysis data set, daily and monthly maps to identify extreme weather patterns throughout 2022 and 2023. And then I am also using the vertical fields from the reanalysis data set to analyze changes in humidity, temperature, and wind direction to understand how those two might be connected. So in terms of results, this is one of the events that we identified, which was March 15th through the 19th of 2022. There was a record heat wave over Antarctica. It was over 5 standard deviations above the normal temperature. Over the climatological 1990 to 2020 climate. I'll go through a few more examples of these. So back to the extreme climates that we had in 2023. This, I think, is the event we had in May is what I think might be the start of what caused that extreme weather that summer, which is a record ridging over Western Canada, and this was between 3 and 4 standard deviations above average. And this caused a blocking pattern over the North Atlantic, so it weakened the winds, which then cooled the sea surface it warmed the sea surface temperatures over that, and it continued to warm through June and into July, where it reached a peak. And this is also associated with the warming of the 2-meter air temperatures over the North Atlantic, which is ultimately one of the main events that would why 2023 was a record warm year. You can see the sea surface temperatures in July on the left are also above 3 standard deviations from the 1990 to 2020 climate. So the ongoing work is working on the vertical cross fields and identifying more of these weather events, mapping them to the timelines, and I plan to defend in this summer. And that is
Do we have any questions?
I have a question. Is there any historical or previous accounts of this occurring in the past, or would this be something unprecedented?
It is unprecedented as far as we know in the satellite. All of the record we have of other volcanoes are terrestrial with a large aerosol, where aerosols are coursing. We have never before recorded this much water vapor being injected into the stratosphere. I forgot to mention, but it increased water vapor in the stratosphere by 10%. So that's a lot of why we really don't know. We've never recorded an eruption like this before.
The event, the stratospheric condition of the excess water last.
Current studies suggest that it can last up to 10 years in the atmosphere. However, the primary effects of the volcano are typically seen within the year after the eruption.
Were there any vessels around during the supposed period that absorbed it?
I am not sure, but I expect there might have been.
Would have been quite sure.
Yes.
Yes. Great, thank you very much. Our next presentation is previously recorded. It's Media Navera will tell us about spatial distribution of PFAS and surface freshwater in South Greenland. Hang on. Sorry, volume is coming out of the laptop instead of the TV, so I just gotta figure out.
Select some in shared, so unshared, select.
The audio settings.
Still shared.
Shift the share button. Advanced sharing, there we go, okay. You may have to stop the share and reshare. And then share. Then you go to share screen. Share screen. Oh, not the carrot, the regular button. Regular button. Let me close this. Advanced. Yeah. Computer audio. Think so. Or share sound here.
Yeah, right. Yeah.
Okay. And then. Go.
And I'm a third-year PhD candidate working with Dr. Paul Majewski, and I'm here today to present our work titled Spatial Distribution of PFAS in Surface Waters Across South Greenland. First of all, I just would like to give some background about PFAS, and since 1950s, PFAS, they have been widely used in consumer products, and also they have industrial applications, especially because of their resistance to heat, oil, stain, grease, and water. And over the last 30 years, efforts involving several organizations such as the United Nations Environmental Program, also the European Chemical Agency, and the US National Institute of Health have been made to identify and also characterize PFAS and their functional groups. The number has grown quite a bit to 9,000 compounds by 2022. And PFAS, they're then synthetic compounds with at least one carbon fluorine, as you can see here on this figure. And because of this carbon fluorine bond is one of the strongest, these chemicals, they don't degrade easily in the environment. That's also the reason why they're known for forever chemicals. They are divided generally into 4 large groups, such as the perfluoroalkyl acid here, as you can see on the slide 2. These two are they belong to the same group. And the length of the side chains broadly classify PFAS as well. PFAS that contain less than 5 carbons, such as this one here, they are considered short chain, and more than 5, such as the PFOA, are considered long chain PFAS. This is really important because higher the number of carbon chains, the higher is the bioaccumulation, and this happens because of the strong bond between the carbon and the fluorine. And a few of these long chain PFAS, they have been very studied in the past decades, and several of these compounds, they have been restricted and also banned, especially due to their resistance and also potential adverse effects on humans and environmental health. But PFAS in the Arctic, additionally to local inputs such as firefighting foams, consumer applications, including our waterproof gear, also food packaging, pesticides, sewage, there is a number of long chain transport of PFAS to the Arctic. This includes long-range oceans currents that transport PFAS from polluted areas, their sources, to the Arctic, and a similar process occurs in the atmosphere. Also, marine aerosols, they have been identified as carriers. And a third type is indirect transport and atmospheric oxidation of volatile precursors, such as the FTOH, which is a different kind of PFAS, and also the CFC replacement compounds. They were introduced in the market after the Montreal Protocol because of the ozone hole, and they can also act as atmospheric precursors to short chain PFAS. Our study area is located in South Greenland, as you can see here, this little red square. And there are a few factors in the area that can increase the contamination of PFAS, such as tourism, people that go there for hiking, kayaking, to visit the UNESCO heritage site. Also agriculture, the place is very famous for sheep farming, and a few mining prospects and closed mines. We went to South Greenland in 2022, and we collected 16 samples, 15 from streams and rivers, and except for one sample. This one was collected in a lake, this one here. And this was the only sample that actually presented PFNA, which is a long chain PFAS. And besides PFNA, we also found other 2 types of PFAS, PFBA, which is spread across the study area in green. And also in the north here, we can observe a predominance of PFPEA, which is also a short chain PFAS. It's really important to mention here that PFAS, they were not detected within any community, and that the highest concentration was observed here in the southern fjord and connected to the Greenland ice sheet. Therefore, all of the observations, they indicate that PFAS, they have been transported atmospheric to the area. And it's also important to say that all concentrations, they fell below health standards, especially for PFNA, the long chain PFAS, which is the only one that is regulated in different countries. I would like to give you all more information about these 3 types that we found in the area. 2 of them, the PFBA and PFEA, are short chain PFAS. The first one here with 4 carbons and the second one here with 5. And as I mentioned before, in 2009, in the Stockholm Convention, they regulated a couple of times of long-chain PFAS. Only 2 out of the 1,000 types that they had at the time. And after that, the production of shorter chain PFAS have increased as a safer alternative to the legacy of PFOA and PFOS, these two that were banned. And different sources also include atmospheric oxidation of different types of PFAS and all.
Okay, I apologize. I've lost control of the laptop and windows are moving around. I don't think anyone has control over Zoom. The green on the top of it, maybe. Yeah, we can try that. So, yeah.
Also the CFC replacements. And at that time, short chain PFAS, typically the studies they showed that typically they had shorter half-lives, and also they were thought to have lower accumulation rates in the human body. But this seems to be very controversial because studies such as Perez et al. 2013 has shown that the mean amounts of PFBA, the short chain PFAS, in kidney and lung tissues of humans were more than 6 times greater than any other type of PFAS. Also, EPA 2022 showed that PFBA also could lead to several issues such as thyroid and liver diseases, even though it does not bioaccumulate as long-chain PFAS. Regarding the toxicity of PFBEA, there is very little research done, and there are a few studies that show that it doesn't accumulate in human tissues. PFNA, the long-chain PFAS, is very similar in toxicity to those that were banned in the Stockholm Convention. To wrap up here, PFAS and other precursors are transported from industrialized areas by the atmosphere and also the ocean. For long-chain PFAS, small concentrations, they can lead to bioaccumulation and also magnification in the Arctic food web, which can then lead to contaminations in humans. And several studies have reported that, including this one in the figure, Son et al. 2023, that showed high levels of PFAS in Greenlandic people, linked especially to high concentrations of traditional Greenlandic food intake in special marine mammals. Short-chain PFAS are still not really well studied compared to long-chain PFAS. We will be going to Greenland in a few weeks to do a similar study, but on the West Coast. And lastly, I just would like to thank you for the presence and thank all of those people here in this slide for the support with this work. Thank you so much. You all have a good day. Bye-bye.
Since Lygia can't be here, I just wanted to make a statement about PFAS. I think a couple of days ago, Dr. Honor Appel, who's in civil and environmental engineering, one of our research colleagues, just became the first director for the PFAS Plus facility at the University of Maine. It's rather large. The university has gotten several $1 million for that. And he sent me a message, which is very important. And I'll read it to you today, April 10th, 2024. EPA announced enforceable levels for 6 PFAS as the final PFAS national primary drinking water regulation. We're witnessing one of the most transformative environmental protection regulatory steps taken by EPA since the Clean Water Act of 1972. Very big. This will change the environmental economy around PFAS by adding new R&D opportunities in all areas of engineering, treatment, remediation, finding material alternatives, understanding PFAS toxicity, impacts on ecological health, epidemiology, new agricultural practices, social justice, material disposal, recycling, tech transfer, and many more. In addition, EPA announced a $1 billion bipartisan infrastructure bill to support states to embrace this change. The Biden-Harris administration is making historic levels of funding available to help implement PFAS treatment measurements and meet the standard. In addition to today's historic final rule, EPA is announcing an additional nearly $1 billion in funding to President Biden's Investing in America agenda to help 56 states. I didn't think it was 56, but and territories, which can be used for initial PFAS testing and treatment of both public water systems and for homes served privately by owned wells. So this is a very, very big deal. What's happening with PFAS?
Next, we have David Buckham, who will tell us about how life stage partition forest inventory and analysis data reveals multi-directional tree range shifts in contemporary.
I shift the name of this. Okay. Hi, everybody. I'm Bailey, for those of you I haven't met yet, and I'm primarily an ecologist and biogeographer. So today I'm going to talk to you about how I use forest inventory data to analyze geographic range shifts in tree species. And if you read the title, I kind of spilled the beans, but let's get into it anyway. So the question grounding this work is pretty broadly, are trees shifting their ranges in contemporary environments? And so my first aim is to understand if we see evidence of geographic range shifts in kind of contemporary systems. And if we do see evidence of that, how are trees shifting and what kind of patterns emerge from our data? And so when I mention geographic range, what I'm referring to specifically is kind of this biogeographic scale distribution of a tree species across kind of the contiguous US in this case in particular. So what does that look like? Well, we can take an example species, this kind of hypothetical conifer, and map its distribution in geographic space using geographic occurrence data. So each of these points in black represents a location where we know the species occurs and survives on the landscape. And then we can encapsulate those points in something like a polygon, measure the center of that polygon, and start to summarize the distribution of this species, or any species. But importantly, geographic ranges are dynamic in time and space. And so this represents a snapshot of the species distribution. But if we're interested in whether and how this tree might change its distribution through time, we can remeasure the range. Oh, we can study geographic range shifts. And so that really is representative of any change in the species distribution over time. So any geographic dimension you might be interested in on a temporal scale. So for this example, we might remeasure the range in a second time step and see what's going on. And so that might look like this now. So visually, we can see that the range has shifted, the polygons aren't overlapping. So at time 1 and time 2, the distribution is different. But we can go a step further and actually understand more specifically how, and start to apply quantitative metrics to summarize kind of how these polygons differ. And so some of those measures we might look at, and there are others as well, are changes in the range size, comparing the two polygons, changes in the position of the range, which we can measure as the difference in the position of the centroid, and then the directional movement of that centroid, and again, over time. And so much of the literature examining these biogeographic scale range shifts to date kind of fall into along these two forking pathways, I would argue, but I am definitely oversimplifying a vast literature in making this point. So we have kind of historic reconstruction from the past on sort of these millennial time scales, kind of retracing past distributions on maybe 10,000 plus year time scales. And then we also have a lot of efforts that try to model or simulate future environments and future distributions of species under various climate change scenarios, for example. And there's less work done at sort of these large scales in contemporary environments. And so when we look to our future projections, we often see these kind of simplistic, largely poleward moving phenomena. But when we look at empirical data from like the paleo record or kind of other sorts of studies like that, what we're seeing actually is that species are shifting pretty heterogeneously, and there's like a lot more complicated dynamics than we traditionally assume. So there's this tension between what we're seeing, what we know has happened, and what we often predict should happen.
So to start to resolve this tension and better understand our current environments, we need a comprehensive empirical evaluation of contemporary environments, which is why there's room to ask that question I started us off with, which is, well, in contemporary environments, are we seeing evidence of range shifts? And so I've been emphasizing the temporal component of range shifts. And so you might be wondering, well, in contemporary environments, where does time come in? And that's a good thought. And in our analysis, we use tree life history stage as a proxy for time. So essentially what we're doing is each distinct life history stage of a tree, in our analysis, it's a seedling, a sapling, or an adult life stage class, represents a different establishment time of an individual species on the landscape, allowing us to effectively embed a temporal dimension into otherwise contemporarily collected data. So how does this work? Well, we would start by taking an example species, again, our hypothetical conifer, and we take all of its available geographic occurrence data and classify that as either a seedling, sapling, or adult, coarsely off of size class designations typically. And then we can plot the geographic ranges as polygons on the landscape. So for this, maybe the adults look like this, the saplings like this, and the seedlings like this, for example. And so if we are seeing evidence of a geographic range shift, we would expect some kind of pattern like this, not necessarily this one, but where the polygons are not directly overlapping. There's some kind of difference in the distribution of the juveniles versus the adults, so that when these adult populations eventually die out, where there's no recruitment, we can expect the range to shift towards those environments, provided those juveniles grow into mature adults. So again, if we look at a different example species, maybe this one looks something like this. So interestingly, we can look at within species variation and understand the dynamics of an individual species, but we can also summarize this across large sets of species to start to detect these large scale patterns. So to operationalize this life stage range mapping approach, what I use and answer this question, I use data from the US Forest Inventory Analysis database, partitioned into life history stage, like I described before, where adults are representing the oldest establishment and seedlings the newest establishment. And I do these classifications for 215 trees in the US, and then start to plot their ranges as ellipse polygons. So we can look at a couple of examples. Here's Eastern red cedar, you see its distribution, and then the three corresponding ellipse polygons capture the range of the seedlings, saplings, and adults. This is what it looks like for black locust, and this is what it looks like for black walnut, and there are centroids plotted there too, but you might not be able to see them well. And I created maps like this for over 200 species, and then started to assess differences in the ranges, comparing the adults to the saplings, so time 1 to time 2, the saplings to the seedlings, time 2 to time 3, to start to understand these kind of temporal dynamics. And the metrics that I'm interested in are changes in the range center, so the distance that the centers move between those life stage comparisons, and then the directions that they move. And so when we do this for all the species and summarize the patterns, what we find is that geographic range shifts are observable in these contemporary environments, and we're seeing considerable variation in exactly how we're observing those. So you don't have to just take my word for it, but I can show you some data now. But we're finding that the center of the geographic range is shifting a distance of greater than 45 kilometers for each comparison. So over here is the adult to sapling comparison, or the time 1 to time 2. And over here is the sapling to seedling, time 2 to time 3. The x-axis is the distance between range centroids between those two comparisons. And then the y-axis is number of species. So it's a count measure, and these are frequency histograms. And then the dotted line is the median. And so in this comparison, we're seeing a median distance shift of almost 60 kilometers. Over here, it's 47, I think. So taken together, the average median distance shift across all comparisons is about 52 kilometers. And so when we start to look at, well, where are species moving and how are they moving, we're seeing that there's movement in all cardinal directions. So now these graphs are against adult to sapling, sapling to seedling, and these graphs are meant to kind of represent compasses. So this is north and this is south, east, west.
And the main thing to take away from this is that there's representation across all 360 degrees of the compass, suggesting that there's no dominant direction that species are moving. It's pretty evenly spread, which is pretty cool. So just to kind of take that together, what we know is broadly, we are seeing geographic range shifts in these contemporary environments when we take this like indirect approach to change through time. And more specifically, we see that the center of the range is shifting an average median distance of 52 kilometers in all cardinal directions. And kind of where I think this fits into the broader literature is that these results challenge a long-held assumption in ecology that is grounded in like really deep-rooted theory, I would argue, where we often expect that under global change and global warming scenarios that species should be migrating pretty uniformly and unidirectionally poleward in either direction. And so that kind of expectation and assumption is underlying a lot of our current efforts to understand change through time, geographic shifts, niche dynamics also. So I hope this can start to advance our conceptual understanding there. So thanks to my advisor and collaborator, Brian, and everybody else who's listened to versions of this.
Any questions for Bailey?
Yes.
Species distributions are as kind of wide and broad as they are on the maps that you showed. Is 52 kilometers a significant distance when you speed shifting, or?
Yeah, I mean, I would say yes, if we think about it. So these are stationary species, so it's effectively like a 52 kilometer change across like one generation. I mean, it's like a population level summary, so that's not an exact like necessarily right way to be thinking about it, but yeah, it's essentially kind of for a stationary species. I think that's a pretty large difference.
I'm really curious about the seedling to sapling to the adult trees and that time period that you're capturing. And so there's our species of 215 trees. So I'm assuming that the reason that you're choosing these trees has to do maybe with that time period is similar across them. So you're looking at similar snapshots in time, or
yeah, so all the data going into the analysis is represented between the contemporary time slice in 2012 2022, and that has to do, that's the nature of the sampling of the data set. But basically the 215 trees are all the trees in the contiguous US for which there's data for that meet like a minimum standard analytical requirements that I set. And then so I think it started off as like 400 trees, but you know, for robustness checks and stuff like that, we whittled it down to 200, but it's still like as far as I know the largest data set. But yeah, it would be really cool to expand this out, but the forest inventory analysis data is restricted to the political boundaries of the US. So it doesn't, yeah, so there's that's also a limitation, but
I think that's all the time we have. Thank you, Bailey. Next, we have Maddie Landrum, who talks about her work reconstructing human forest relationships in Maine.
Hi everyone, Maddie, it's good to see you all a year later. So today we're going to talk about a big question that we have in Maine, which is what is the human role in Maine's forest and fire climate relationship? Which, despite the robust history of paleoecological research within the region, hasn't really been examined extensively. So you can see here from the figure by Munoz et al. That there have been a number of paleoecological studies specifically focusing on pollen and truffle, are proxies for vegetation composition and fire history within the area. And this is not extensive, there are a couple others that are on Utah. But a lot of these are addressing more regional processes. So what's really complicated is that Western science doesn't actually agree on Maine's fire history. While regional processes have been really well documented, the human versus climate drivers are not well explored, and nor are some of these local processes. Thankfully, this has been done successfully in other parts of the world.
they have been able to disentangle human versus climate drivers, but these are primarily in the southwest, lake region, Midwest, and out west, so not a whole lot on the East Coast. So we're going to examine this now through a sediment core collected from Witch Hole Pond, which is on Mount Desert Island in Acadia National Park. And to provide some context of the rich history of this area, we have some of the archaeological sites viewable here on this map. The oldest known site from this area dates back to approximately 5300 BP, which is Turner Farm. And you can see the next three oldest dates are really within the 4000 BP range. And what's really neat about the oldest sites here is that they kind of show the development of some of the shell heaps in the area. So they show the rich marine resources that become available at this time. For example, around 5000 BP to 3700 BP, we have the appearance of swordfish, of cod, and of a bunch of different bivalves in the area, making it a really marine resource rich area. And in the star there we have Witch Hole Pond, just for reference. The Wabanaki people have a really rich cultural history with this area, which can be further demonstrated by some of the place names from the area. And this speaks to the resources as well as some of the relationships at the area, such as Schoodic, like Schoodic Peninsula in Acadia National Park, means at the bird place, or Menisatic means at the clam gathering place. And you can see that one is right next to the coring location. So to start looking at the records we found in sediment cores, we're going to start with pollen to look at vegetation assemblage. And here we have a bunch of graphs looking at changes in pollen over the last 6,300 years. This is a lot of information. We're going to skip most of that. So here are some of the pollen types of real interest that we're looking at. So over here, we can see that this goes back approximately 6,300 years, and we have our relative percent abundance of those various pollen types. And then in our color blocks, we have our pyrophobic or largely fire intolerant species in blue. We have our paraphilic or fire loving species in red, and we'll call them pyrobenefiting species, which are in yellow. Most of those, interestingly enough, are food producing species. And what's really cool about this is prior to the development of the archaeological record, we see a high percentage of pyrophobic species, though we do see pyrophilic species and pyrobenefiting species present. But that relationship changes with the development of the archaeological record. We can also see the hemlock decline, which occurred regionally right over here. We see this huge plummet in hemlock on the landscape. But instead of being replaced by things like maples or beeches, we start to see them being replaced by a lot more of these dipoxylon pines, which are Pinus resinosa and Pinus banksiana, as well as these more food-producing species. And so when we start to plot this and look at the relationship between those pyrophobic and pyrophilic species, we see that prior to the development of the archaeological record, there's a greater abundance of pyrophobic species, although our pyrophilics are still present. But that relationship starts to change with the development of the archaeological record. And as we start to see the decline in some of the marine resources like swordfish especially, which is one of the big indicator species, which again declines at 3700 BP, we see that separation of pyrophobic and pyrophilic species yet again. And so when we take this a step further and bring in our pyrobenefited species, we see it's also kind of confusing here. The relationship changes as the archaeological record develops, and the food producing species actually remain relatively high, even with the decrease in marine resources. So now that we've kind of looked at what's going on with the forest, let's look at some other proxies, such as our radiocarbon dates, which are providing our timeline for all of this, thankfully, charcoal to get at our fire regime, and lipid biomarkers, which are an emerging proxy used for human presence on the landscape. So first, looking at charcoal, we have our charcoal accumulation rates from Witch Hole Pond, accumulation rates here on the Y, with time on the X. One of the big things to note here is this record goes back to 12,000 years, so it's almost double the previous one. And we have our peak fire events marked here with red pluses. And what's interesting about this record is we kind of have two distinct fire regimes. We see a change, again, right around the time of the development of the archaeological record, where peaks go from high peak magnitude to low peak duration
to low peak magnitude, but more extended duration, with the duration lasting on more of the centennial rather than decadal scale. And to further dig into this, we see from climate records from Newfoundland and from Massachusetts, unfortunately there aren't any from Maine that I have found. If any of you know of any, please let me know. That the area was going from warm to cool to warm, and warm, wet, warm, cold, dry to warm, wet again. And we know this from regional lake level records, which a lot of them have come out of the Climate Change Institute, which has been wonderful. So what's interesting here is if we think back to those column records, this drought is happening, or this lake level drawdown is happening at the same time as the hemlock decline. So it's dry, there's a bunch of people on the landscape, and yet we don't see an increase in fire or an increase in charcoal. However, we do see the development of the archaeological record. So something is changing here, and it looks like there is a factor mitigating the effects of climate or of the environment, which could be human presence or change in human relationship to the landscape. And this is made even more interesting when we add in the lipid biomarker record here in blue. So we've got our same charcoal accumulation rates, but lipid biomarkers are an emerging proxy used for human presence on the landscape. The reason they're so effective is because humans produce copper channel at 20 times the rate of animals within their gut microbiome. And so everybody poops, everything poops, it all ends up in the water. So we are able to distinguish the lipid chains within human fecal matter from that of herbivores and other animals. And the only other creatures that that could be confused with would be seals and pigs. And so this spike in lipids here may be due to seals being present when the Laurentide ice sheet retreated and the marine inundation came in. But once it recedes, we see that we still have copper channel, even once this area is separated from the Gulf of Maine. And our record actually cuts off really before European arrival and the introduction of pigs. So with this threshold here, we see that when our ratio of copper channel to stigma channel is our herbivore indicator, copper channel is our human indicator. When that ratio is above roughly 1.5, we can say that it is people on this landscape. So even though the archaeological record goes back to approximately 5300 BP, the human history, the people's history goes back much further. And so what we're finding here, this is not the only study where we're doing this in Maine, we've got a series of them, is that Maine has highly localized records. There are different relationships between people, plants, fire, climate, all across this landscape. And we need to better understand those to figure out how our systems are going to respond in the face of climate change. I have so many people to thank for this work, from funding agencies to collaborators and people we're in consultation with. And also thanks to the Curriculum Fund for funding our initial fieldwork experience in the area. If we have time, we'll end with our land acknowledgement and taking questions.
Any questions? Thank you, ma'am. The blue line on your graph, that's the for proxy for humans. Why it's really high 12,000 years ago? Is that saying that there were more people at that time?
I think that probably could be influenced by the local seal population.
Can you say that again?
That may be influenced by the local seal population because they also produce high levels of copper channel. So, you know, as the Laurentide retreated and the Gulf of Maine came inland all the way up to Bangor, it inundated a lot of this landscape. So it didn't retreat until roughly 12,200 years ago, depending on where you are in Maine. So it could be that seals were hanging out and playing in Witch Hole Pond, living their lives in Witch Hole Pond. But by the time that inundation recedes, we still see people. So there could be people present during this time, but it could also be skewed by seals in the landscape.
Okay, time for one more.
What's your interpretation of the break in the fire record?
This one?
Maybe I missed it, yeah. 4,000,
Yes, so because that happens at the same time as the development of the archaeological record during a time of drought with also high fuel loads in the landscape. I believe that people were changing either the fuel available on the landscape through collecting firewood or conducting low intensity burns to clear their landscape and also foster the growth of those food producing species. Because while not all of them require fire to exist and persist, a lot of them benefit from it. So it could be that people were intentionally shaping their landscape to be more food rich, while they were also living during a time with increased marine resources. So
Is there much evidence for fire management?
that's the big question. There are a lot of oral histories and place names that speak to it. There are some historical records that speak to it as well. But there aren't a whole lot of paleo records or dendrochronological records that explore that because of the land use history. I mean, so much of it has been logged. It's difficult to disentangle the human influence within that kind of record.
Thank you.
Thank you.
Next we have Sandra, who will tell us about constructing the beryllium 10 technology on late Holocene glacial in the Southern Alps in New Zealand at 43 degrees south.
Thank you for that mouthful. Hello, you are now stuck with me for the next 10 minutes while I talk about my very exciting work that I have been doing the past 2 field seasons. I get to escape the nasty winter here and go to the Southern Hemisphere where it's nice and warm, where we've been exploring the Holocene, trying to uncover global climate dynamics through beryllium-10 dating of glacial boulders in New Zealand. So the objective of my work is to collect and obtain evidence to determine if the Little Ice Age and medieval warm period were global events. And then we can begin answering questions such as what were the global climate dynamics during that time? What were the moraines phasing with elsewhere, and what can that tell us about these global climate dynamics? Are they controlled by insolation, solar variations? Is it some sort of internal ocean atmospheric variability? Is it some sort of forced stochastic variability via volcanoes? Who knows? That's my job, not yours. To get us started, so we're all on the same page, let's just define what the Little Ice Age was. It is a term that's used to describe a period of time between the late 13th century and ending around the late 18th century, where it was just generally cooler and allowed glaciers to expand and advance to more advanced positions than the previous centuries before, and then the centuries that would follow after. It was a term that was initially introduced into scientific literature in 1939 by Mathis. We use it to describe an epoch of renewed but moderate glaciation that followed the warmest period of the Holocene. This is a painting, I believe, by some Frenchman that's on the cover of a really good book that I recommend called Nature's Mutiny that goes all over the Little Ice Age. Now, most of the data that we have for the Little Ice Age comes from the Northern Hemisphere, as we actually have historical accounts from it, as it was very notable for its detrimental effect on European agriculture during the late 13th and early 14th century. This is a figure that I borrowed from Man et al. 2009, decadal surface temperature reconstructions. There's a lot going on here, just pay attention to this. You'll fail if you do this. Okay, so on the y-axis is just temperature anomalies in Celsius, ranging from -1 to 0.5, and then the x-axis is just the year AD. And this red box is the generally agreed upon time for the medieval warm period between 950 and 1250 AD, and then this blue box would be the Little Ice Age from around 1400 to 1700. All you need to know: warm, it's nice, wear a t-shirt, it's cold, my crops are dying, sad. So in order to approach those questions and determine the true extent of the Little Ice Age, we're dating glacial moraines. Why and what are they? So moraines are glacial landforms that are the result of rocks and materials deposited by the glacier that just keep accumulating along the extents of the glacier, either the sides or the terminus of it, and it just keeps piling up and piling up. And they represent just previous extents of the glacier. That's what you can see in these two images. There are these sinuous features. And we can then date boulders on these to then date that feature itself and get an idea of what the glacier was like in the past. And since glaciers are so reactive and sensitive to changes in temperature, we can then derive from that extent of the glacier what the climate was like in order to allow the ice to be at that point at that time. So now that we know that we're dating moraines, we have to decide what moraines and where in New Zealand. It's a small country, but it's not that small. There's a paper by Birkeland in, I believe, 1989 or 88, somewhere in the 80s, that has that broke it down as subdivisions of Holocene glacial deposits that was used for relative dating methods before we had cosmogenic dating. And it's based on the weathering schemes of a lot of these glacial boulders. All the boulders you're going to be looking at and all the boulders that we collected are of a gray-wacky lithology. The youngest, known as Dunfunery, is one of the easiest to identify in the field. It's very boring. It's just gray. It's very angular. There's no knocked corners. The quartz veins that you might see in these rocks are all flush with the surface itself. There's little to no weathering vein. There's no lichen. There's usually no pitting. It's a very fresh rock. Getting a little bit older, this is now Whale Stream. It's still a very young rock, but the one major difference, as you might be able to see, is that these rocks now have a pink oxidation color. When exposed to the atmosphere for a longer period of time, that has allowed the iron content in them to react with the oxygen and turn this nice pale pink color, but it's still very young. There's usually not too much lichen population on them just yet. The corners are still very angular, and the quartz veins are still flush with the surface of the rock. There's usually little to no pitting. Grad student for scale. Getting a bit older, then we have Jack Stream and Farintosh weathering. They're both very similar. They're just Farintosh is a bit older, so the weathering is a bit more exacerbated. The oxidation now turns it to a more vibrant red color than a pale pink. You actually start seeing more relief of the quartz veins relative to the surface of the rock. The corners of the rock might start becoming a bit more rounded and knocked. You actually might start seeing larger lichen populations, such as this image on the left, on the right. And there might be more pitting as well. How I like to describe it out in the field and in my notes is that the quartz veins almost represent kind of spider web symbology, I guess. They're interweaving one another, and they're very noticeable. You know what you're looking at when you're looking at a Farintosh or a Jack Stream. And then the oldest of the old, Birch Hill. These rocks have been here for quite a while. They're bored, so they turn gray. They're no longer a vibrant pink or red. The quartz veins have very serious relief of multiple millimeters above the surface of the rock. They're actually quite well rounded relative to, say, Dunfunery or Whale Stream. There's lichen all over it. They love it. And there's usually a lot more signs of weathering, pitting, cracks, and crevices. So we would be focusing mostly on areas that had this Dunfunery and Whale Stream weathering, as those would be the youngest rocks. So in the past two field seasons, 23 and then 24, I have been to 3 separate field areas that are marketed by these colorful diamonds. There's the Upper Elsa Valley, which is just north of just north of Lake Bukaki. Then there's actually Tadman Glacier. It's the largest glacier in New Zealand. We are actually camping just to the west of it, just to the east of it. And then there's South Ashburton, which is a bit more northeast of up the Southern Alps from my previous 2 field areas. This is a very simple map of my area from Upper Elsa Valley. Getting situated, the black are the ice compact slopes of the moraines we walked, and the yellow dots just represent the samples that we collected. These are pictures from the field, as you might be able to see, hopefully, that this innermost moraine here has that dun funerary gray appearance to it, and the one outboard of it has a more whale stream pink. So what that tells us is that some event happened here that caused a resurgence of the ice. Same thing, but this one is now for South Ashburton, same symbology, black for the ice contact, the little dots representing where we actually collected the samples. In 23, it actually snowed, but these moraines are actually so steep and so large that not a lot of snow actually covered the rocks on top of the crests. And then we returned back this previous year and we were able to spot a lot more that wasn't covered by feet of snow. And then the last one, the Tasman Glacier. This Tasman Glacier would be right here. And then there's a large lobe of these much younger moraines that we took samples from. We chartered helicopter flights out there. That's the Tasman Glacier there. And then this is what it would look like if you're actually on the ground walking the moraines. Now, to collect the data, like I said, we charter helicopter flights. We find a relatively flat area to set up camp. We get tormented by wind. Sometimes we eat up our tent and we have to get another tent sent out to us. But we were tough. We go back up, trace these moraines, and then target large boulders that we're confident has not moved since its deposition, blast off the top surface and bring it back with us. Now, I don't have any dates just yet because these are very stubborn rocks and they're very young, so they need a lot of material. But we do have some ages from a similarly weathered area near Whale Stream. Very quickly, this is WS 2310. It has a more dun funerary weathering scheme and it had an age of around 360 years ago. WS 2304 had a more Whale Stream weathering scheme, more pink, around 8,000 years ago. Okay.
For one question for Xander. I was wondering, why there's a reason, you studied the East Coast glaciers, not the West Coast, as the West Coast, as far as I know, are steeper and less covered by dirt. And now we're often told to have a faster time of response than the East Coast glaciers.
That's a good question. As far as I know, we're trying to cover just about the entire South Island. So right now we're just focusing more on the East Coast. I know on the West Coast, they're much more responsive as the westerlies drop all the rain and precipitation there. And I'm not sure if the plan is to save those for last. Work has been done out there, but it's a lot easier to argue that these glaciers are responding to temperature changes if they're on the eastern side of the Southern Alps. Thank you.
Next we have Fatima Fahani, talking about how high vapor pressure deficit and low total water content causes xylem embolism in Mediterranean pine.
Hi everybody, I'm Fatima. I'm advised by Yongzhen Sang and I'm from SV and also Trojan Institute. And today I'm going to talk about how high vapor pressure deficit and low water content causes xylem embolism in Mediterranean pine from trees rather than xylem. So something to recap, and we all know that temperature is increasing, and this is a temperature change pattern of the past 100 years, and then the prediction that's also coming 100 years. So what you're saying is the observed pattern, temperature is increasing, and under all carbon emission scenarios, temperature is predicted to increase. Next, along with that, we're saying this drought is also predicted to increase along with vapor pressure deficit. I'm going to refer to it short as VPD. The first figure is a global drought map, and the red area shows the prediction that soil moisture in top 10 centimeter area is going to be really, really dry by the end of the century. And vapor pressure deficit is simply an indicator of how dry the area is, but then I put the definition here, and the prediction also shows that vapor pressure deficit also going to increase by a lot by the end of the century. So what happens with this rising temperature, drought, vapor pressure deficit, what we're already seeing is this global pattern of forest dieback. So great points are the points where we're seeing this forest diabetic pattern all over the world. And they're followed in Europe, Asia, North America, Australia, everywhere. You see there are these patterns. But then scientists have been trying to understand what is causing this. Of course, it's related to high temperature, drought, precipitation effect, but then also to physiologically trying to understand why it's causing and how it's happening. It's mostly related to hydraulic failure caused due to xylem embolism and carbon starvation. But then I'm going to walk you through what that means. So there are so many failure modes that could arise when water is being transported inside the xylem vessels. So there are so many modes, but then I'm just going to talk about these two. One is the formation of cavitation, and it's simply the formation of air bubble inside the xylem vessels. And why that happens and when that happens is when air temperature is too high, vapor pressure deficit is too high, but then there is no water on the soil, there is a drought happening. If the pool is so high, it cannot satisfy that transpirational demand. It spreads and breaks that water column, and air seeding happens. Because of that, air bubble forms. And when the transpiration pool is so high and tension keeps on increasing, that xylem vessels get blocked by too many air bubbles that are there. And that's what we call it embolism. And it causes the blockage of xylem vessel, and it leads to hydraulic failure and death of plant. And we see this global pattern for that as well. So I might be referring cavitation, embolism interchangeably, but it's the same thing that I'm trying to say. So why do we need to study this is there has been a lot of research done, not to mention about all the research that have been done to trying to figure out what is happening with the trees. That scientists trying to understand time response to a combination of soil drought with high temperature, high pressure deficit. But then what is missing is they're not being able to isolate these physiological effects of rising pressure deficit or temperature with plants on their low soil moisture or high soil moisture condition. So what happens with that gap is it limits our ability to anticipate impacts on this terrestrial ecosystem, which is mostly forest. And another problem with this is it's difficult to isolate this physiological effect. It's difficult mostly because this entangling vapor pressure deficit temperature and scale conditions is incredibly difficult. So we need this controlled environmental condition or experimental setup to actually understand how plants may be killed with this vapor pressure deficit and low soil moisture condition. So in order to understand some of those and to fill the gap, I traveled to Israel, which is funded by postgraduate fellowship from SPE in the spring of 2023, and also to learn from this world-class expert in hydraulics and design an experiment so that I could understand how this vapor pressure deficit and low soil moisture could cause death in Mediterranean pine. And why Mediterranean region, why pines is mostly because we see a lot of this heat wave effect. The frequency, intensity is increasing and it is continuing to rise. And pines is mostly the most dominant conifer tree species in Mediterranean region. And what we're seeing already is there are literatures that say that they're already shifting the range or shifting the distribution towards the dry areas of their distribution. And it's a problem there. So the idea to go there and learn was also to, and for the transfer of technology, so that I could use the techniques, whatever I learned in Israel to understand drought resistance of this northern United States forest at home, and that's part of my other PhD discipline as well. So the goal of my study was to test if high vapidity on the drought and worldwide condition causes xylem embolism in Mediterranean pine. It's difficult, but then there are two concepts that we need to understand, and I'm going to walk you through. The first concept is what happens when there is high temperature, high vapor pressure deficit in atmosphere, and there is enough soil water content. Under that condition, even though there is high transpiration pool, there is water to supply to the plant. Under that condition, you don't expect embolism to form or cavitation to form. So there is other condition when there is high air temperature, high vapidity, but there is no water in the soil. Plant can only satisfy the transpirational demand at a certain point, but then when plant run out of water, it leads to the formation of embolism. So what embolism causes to the plant is it causes hydraulic failure, carbon starvation, so death of a tree, forest die, that pattern. So this is a problem mostly because this produces compound effect. And this is a compound extreme when high vapor pressure deficit temperature is coupled with low soil water content. So compared to if high vapor pressure deficit was there, it would not produce that much effect compared to if it's combined with drought. Yeah. So there are so many ways in which you can quantify embolism or cavitation happening in plant. I'm just going to talk about what I did. So I use this optical method, and it's a really cool method where you can see this embolism happening in a live plant. But all of the methods that I use here to study drought resistance in the past was by the destructive method, which I had to cut the tree branch to look the embolism formation. But here I use this chemical sensors. These have this Raspberry Pis, and they act like a small computer, and you can program it and they help take image every 5-minute interval. And it can take images for a week, for days, and for months. And it also has this, it's labeled with 5 on the top, so it has this camera, and it has the storage unit, and then it can take the images. So it's really cool. And the way it takes images is differently when there is water present in xylem vessels versus when there is air present in xylem vessels, because of the difference in reflectance produce at the time of air formation. So this is how an experimental setup looked like. I did this experiment in a plant growth chamber, and I had this 10 plants in total. 10 plants are well watered, which means the plant have enough supply of water, and on the other side there are 5 plants where they don't have enough supply of water. It means that they're drought treated already, and each of these plants are fitted with a chemical sensors to this thing, so I know within the experimental time period what is going on within the live plant. Okay, and at the same time I'm recording these physiological parameters like plant photosynthetic rate, stomatic conductance, water potential, and all this phenomena when the experiment is going on. And the experiment starts from day 1 with low temperature to I keep on rising the temperature. Along with that, BPD also rising changing. So there are a lot of things that go into preparation phase on how you're going to expose the xylem with dosing. I'm not going to cover. It's a lot of work, and also because of the time constraint. But then I'm going to walk you through some of the results that I found. So what I found was left is a well watered and right side is a drought. So I found cavitation happening under both well watered and drought conditions. Like which I said previously in the gold slide, it didn't happen. It's something that we expected, we didn't expect, and but we saw cavitation happening even on the well watered condition and even on the drought treated condition. So black lines is the cavitation line, and blue line is a vapor pressure deficit line. So this is on our x-axis is the time, days, and in hours. So as vapor pressure deficit increased, or towards the end of the experiment, cavitation also kept building. So cumulative cavitation kept building, right? But then in both conditions. So one thing to note is on the drought condition, you see 100% cavitation happen, but on the well water, they didn't reach up to 100%. Means that number of events on the well water condition is less compared to the number of events that took place at the drought condition. But then there is some inconsistencies with this. These are just the preliminary results. Why inconsistency is because on the drought, if you see 100% cavitation happen, you would expect all the xylem vessels to fail, means that they are all embolized, and you would expect plant to die. You see the visual symptom, but with the pines, I didn't notice any of the visual symptoms. Yeah. So what I'm trying to do is trying to design similar experiment and also use other technology like microCD to validate the optical method and also the similar experiment in the fall of 2024. So some of the takeaway messages from this is high BPD and low soil moisture causes xylem embolism on the both well water and drought treated condition. But then what happens is there may be so many events on the drought, but number of cavitation events are lower on the well water condition. And another is it might not be possible to see visual symptom in conifer, probably because the leaves are thick and they take a long time to dry and actually show the visual symptom. Whereas in deciduous, if cavitation is 100%, you see the leaf wilting, brown, orange color, all those visual symptom. But it takes time for conifer to show that symptom, even though they die physiologically. And we need this microCD method to actually validate our finding and to actually say, okay, cavitation happens in the water condition, and if this is a natural phenomenon that we see on a day-to-day basis. I wrote to thank so many people, how this fellowship and everybody involved in it.
Any questions for Fatima?
All right, thank you very much. Our last presentation for this session will be over Zoom, so bear with me while I switch over. All right, Erin, are you present on Zoom? You should be able to share your screen now.
You're muted also.
Okay, can you see that?
We see your presentation format rather than the slides.
Oh, okay.
There we go. That looks correct. Yeah, go for it.
Hi, everyone. My name is Erin Victor, and I'm a PhD candidate in the Anthropology and Environmental Policy program in Department of Anthropology. And I really just started my dissertation research on a packaging waste management policy called Extended Producer Responsibility for Packaging. And since I just began on that research, I don't have much to share with you about that. So I wanted to take this opportunity with the mini paper and the Born Symposium to talk about or to explore further ways that waste management and plastic packaging in particular intersect with climate change. So that's why I'm focused on the idea of plastic waste as a potential feedstock for renewable fuel. So plastics were originally framed as an environmentally friendly solution to scarce and over-reliance on scarce resources such as ivory and tortoiseshell. Today, however, they are largely seen as one of the most pressing environmental challenges of our time and are associated with marine plastic pollution, human health risks, including cancer, infertility, and impaired neurodevelopment. And it's estimated that plastics in the ocean will outweigh fish pound for pound by 2050. When measuring the global production, use, and fate of all plastics, researchers found that the plastics generated as of 2015, only 9% had been recycled, 12% were incinerated, and 79% leaked into the environment. They argue that humans are conducting the singular uncontrolled experiment on a global scale in which billions of metric tons of materials will accumulate across all major terrestrial and aquatic ecosystems on the planet. And recent evidence further suggests that the current production of these, what they call quote unquote novel entities, outpace society's ability to assess, monitor, and address the risk of plastics in the environment. Packaging, which you can see from this image, makes up the largest portion of plastic production, with 40% of plastic being produced as single-use packaging, which is the impetus for regulations like EPR policy, which is the focus of my research, where it's trying to incentivize producers to eliminate, reduce, or redesign more environmentally friendly packaging. Interestingly, despite being a complex group of synthetic materials that are predominantly made from petrochemical feedstocks and require considerable energy inputs into the synthesis process, the connections between plastics and climate change are just starting to gain attention. In 2021, reports from the group Beyond Plastics at Bennington College found that the US plastics industry alone accounts for more than 232 million tons of CO2 gas emissions each year. That's the equivalent of the carbon emissions from 116 coal-fired power plants. If the current growth in plastic production continues, plastics are expected to account for 15% of the global production of, or the global carbon budget by 2050. Here you can see an image from the Center for International Environmental Law, which has a similar trajectory of the annual emissions that are calculated throughout the plastic's entire life cycle, contributing to carbon emissions equivalent to 615 500 megawatt coal-fired power plants by 2050. So this is where plastics as a potential fuel feedstock comes in. Many circular economy proponents are looking for technological solutions to address the growth in non-recyclable plastic waste. And at the same time, there's been a considerable investment in biofuel production in order to reduce carbon emissions in the transportation sector. Technologies that convert waste into fuels, including plastics into fuel technologies such as pyrolysis and gasification, are thus heralded as a win-win solution. These waste-derived fuels promise to reduce the amount of waste sent to landfills, generate a valuable fuel product, and lower carbon emissions compared to petroleum-based fuels. Furthermore, unlike first-generation biofuels, which are made from food-based feedstocks such as corn and soy, waste-derived fuels are or they won't result as much land change or displace farmland for food production. Under the Renewable Fuel Standard program, which was first created under the Bush administration in 2005 as part of the Energy Policy Act, which amended the Clean Air Act, it was seen as a method of increasing energy security to reduce reliance on oil and gas imports, and also a way to decrease greenhouse gas emissions in the transportation sector. In a nutshell, the program is a national policy that requires a certain volume of renewable fuel to replace or reduce the quantity of petroleum-based transportation fuel, heating oil, or jet fuel. In 2007, the Energy Independence and Security Act expanded this program, increasing the goal to 35 billion gallons of renewable fuel, specifying yearly volume requirements through 2022, and defining what qualifies as a renewable fuel, including a required greenhouse gas emission reductions for each fuel type. While we typically think of renewable biofuels as those from starch feedstocks like corn and grain, the program also allows for what are called advanced biofuels. And here is, it's specified that fuels made from waste feedstocks, including municipal solid waste, were eligible to qualify as advanced biofuels if they could demonstrate a 50 to 60% reduction in greenhouse gas emissions compared to petroleum-based fuels, and if the EPA approved plans by the manufacturers to remove recyclable materials from their MSW-derived feedstock first. However, in January 2022, the EPA announced a new effort to streamline the review and approval of new chemicals under the Toxic Substance Control Act. And that was in order to support this RFS program, and that was supposed to help streamline the approval of including waste-derived biofuels. So under these streamlined rules, it's unclear whether waste-derived biofuels will need to meet the target greenhouse gas emissions that were originally set up, and whether or not plastics to fuel projects will count as renewable or not. And so there's a lot of speculation that they will. And as of April 2023, the EPA has processed a total of 35 submissions under the new fuels approach, of which 17 expect to be manufacturing using some feedstocks made from plastic waste. So plastic to fuel technologies, they're a subset of a technology being advanced by the petrochemical industry called chemical recycling or advanced recycling. These are emerging in a diverse set of technologies that use high temperatures or chemical processes to break down plastics into their chemical components through pyrolysis, gasification, or purification. And while some of these technologies can produce monomers or polymers that can be turned back into new plastic products, thus the name recycling, most of the existing facilities today utilize pyrolysis, which is a conversion process, which produces mixed hydrocarbon products in the forms of oils, gases, waxes, and char. It is not a new technology at all. Plants were built back in the 1980s, and it uses high temperature and high pressure to be in an oxygen-free environment to break down polymers. And while it requires less pre-processing or sorting than other technologies, which means it could better utilize mixed plastic waste. It's the most energy intensive and has the lowest material processing efficiency or yield. So despite the optimism around plastic to fuel technologies, the economic feasibility and scalability of these technologies remains unproven. And they're expensive to build and operate. Most facilities have failed, or in the ones that are currently operating in the US are not running at full capacity. And even if these facilities do manage to scale, they will require a constant feedstock of plastic waste, which creates a lock-in effect and detracts from solutions that address the unsustainable production and consumption of plastics. The greenhouse gas reduction emissions of waste-derived biofuels are also very questionable and highly dependent upon how the calculations are done, the quality of the waste plastic feedstock used, and which heat is used in these technologies and which solvents are used. According to Bell 2023, pyrolysis requires a continuous supply of heat over prolonged periods and needs to be able to respond rapidly to what is a very sensitive process. In modern pyrolysis plants, the heat comes from burning natural gas and diesel oil. Despite some claims, the process will not self-sustain on its own gas. And then life cycle assessments, such as the ones you can see in this picture, they analyzed a bunch of different life cycle assessments, and it suggests that chemical recycling has a higher climate and environmental impacts over what's traditionally you think of as recycling was mechanical recycling. So most concerning, however, is the human health hazards generated by these facilities, which are predominantly cited in environmental justice communities. Plastics contain numerous toxic additives such as flame retardants, PFAS, phthalates, BPA, and metals, which are known human carcinogens and neurotoxicants that are released as air pollution and hazardous waste byproducts from these facilities. And one waste-derived fuel approved by the EPA under the new streamlined guidelines announced in 2022 was estimated to release toxic emissions, which could cause cancer in 1 out of every 4 people, which is just an unheard of rate. And these, furthermore, these facilities frequently catch on fire. So while plastics to fuel technologies may seem like a win-win for solving the twin problems of plastic waste and decarbonizing energy, the considerable human and environmental health risks of plastic-derived fuels raise flags for environmental justice advocates. And as this figure puts it nicely, chemical recycling, including plastic to fuel technologies, are essentially just a fossil fuel merry-go-round. So I wanted to thank my advisor, Dr. Cindy Eisenhower, and funding from the Canadian American Fellowship, and open it up for questions.
I think this time I'll open it up if there's anyone on Zoom who would like to ask a question, and then I'll scan around the room here. Seeing none on Zoom, anyone in person have any questions for Erin? Yes.
Does anybody have any idea how much federal money has been invested in this?
I was actually just reading a New York Times piece about that. It didn't specify how much, but there is a considerable amount of like public-private partnership where government dollars are going into these facilities. Yes. I don't have a ballpark figure though.
Any other questions? All right, thank you, Erin.
Let's start our second session. And happy to introduce our first presenter for this session, Kate Hanley, and she will be presenting Indigenous Connections to Maine's Interior Landscape, an evolution of the environmental context of the Sebasticook Lake Fish Weir Complex. Please.
Thank you. So I'm going to be talking about a project today that builds actually on the work of a bunch of UMaine and CCI folks from the past 30 years, which is kind of nice and cool to be part of that legacy, including people who were part of CCI. So really the purpose of this project is to basically contribute a multi-proxy paleoenvironmental record of the to basically complement the archaeological and geoarchaeological work that's already been done at the Sebasticook Lake Fish Weir site. This includes the addition of fecal lipid biomarkers, which are an emergent proxy that Maddie talked a little bit about in her presentation. That's basically been used in other settings to directly detect a signal of people in a watershed and human activity within a watershed. And so this was the first study of its kind in the Northeast to evaluate whether or not fecal lipid biomarkers were going to be a viable proxy for the Northeast. And we have some really exciting results that are kind of hot off the presses. I'm going to pare them down to just a select few proxies, and then if you're interested in it, I will be defending my dissertation in May, so you can come and kind of see the full story then. Yeah, exactly. I've been here for a decade. I gotta get out here. But yeah, so the Sebasticook Lake Fish Weir Complex is the location of the oldest known fish weir site in North America. And Sebasticook Lake falls within the pre-dam ranges of anadromous alewives and Atlantic salmon and catadromous eels, and has a bunch of other local species of fish as well. Sebasticook Lake, whose Wabanaki name means almost through place, was also an important site for the Wabanaki and Abenaki people because it provided easy passage between the Penobscot and Kennebec watersheds. Archaeologists identified over 630 fish weir stakes from right in this area where the modern channel is. At one point, the channel shifted over to this area, and then it shifted back, and I'll talk a little bit about that in a second. we took our core from the deepest basin that was close to the site right out here in Sebasticook Lake. The Sebasticook has extensive development around the lake edge. It's a major agricultural area, and the introduction of a dam artificially raised the lake level by 2 meters above its natural level, which basically means that there are very few archaeological sites and little cultural material left in the area that can provide contextual information for the fish weir site. Importantly, the site would have brought large numbers of people to the site and concentrated their activities directly at the lake edge. And it was used for almost over 5,000 years. So that made this location a really ideal site for testing whether or not we can detect lipid biomarkers, fecal lipid biomarkers, and whether or not they're telling us what we think they are. So human fecal biomarkers are a direct and continuous proxy for humans in the sedimentary record. Human fecal biomarkers are lipids that are specific to the human gut and that are excreted in human feces. They make their way in small amounts to water bodies where they bind with sediment and then are deposited at the bottom of those water bodies along with other proxies like pollen and fire and charcoal. Charcoal, not fire. And this is really important because it basically has the potential to fill in major gaps in the archaeological record, as it allows us to directly compare humans to changes in things like fire and vegetation, which is really cool. So the main biomarkers that I'm interested in are copper stanol, because the human gut produces enormous amounts of copper stanol, much higher than any other animal. The next closest is seal, like Maddie said in her presentation, and pigs, which were not a native species here in Maine. And so, okay, there it goes. And so I was looking at copper stanol as an indicator of humans and stigma stanol, which is an indicator of herbivore populations. So we basically set out to test, can we detect lipid biomarkers in Maine sediments? And if so, what can we learn about the human activity in important cultural areas with the use of this novel proxy? So we're going to spend a bit of time building this figure together. So I just want to orient you really well with what's going on, because you're pretty much going to be looking at this for most of the presentation. So we have age on the x-axis down here, starting at 0, which is 1950, and then it extends beyond that to the modern period. And then it goes back to 7,500 calibrated years before present. At the top, we have just kind of the broad cultural periods in Maine. So we have the Archaic, in the dark green, bright green was the Susquehanna, brown is the Ceramic period, and then purple is the Historic period. Importantly, on this figure, the gold bands here represent periods of active fish weir use. So those come from those basic those panels come from radiocarbon dated fish weir stakes. And so we know that the fish weir complex was actively being used during those intervals. This red band here marks a period when lake levels were 9 meters lower than they are today. And then basically that disconnected the lake basin from its outlet, meaning that there was not access to migratory fish populations at that time. And then the blue band at the far end is the Little Ice Age. So the first record we're going to add here is stigma stanol flux. So as a reminder, that is an indicator of herbivore populations. And I cut off the y-axis because with the introduction of livestock during the historic period, stigma stanol flux went through the roof. So I've kind of shortened that y-axis so you can see littler changes that happened prior to that. Then we have copper stanol flux, which is here, the same thing with copper stanol. So I've cut off the y-axis because, again, with the permanent settlement of Europeans at that time around the lake edge, you get a really big copper stanol signal. So you can kind of see those fluctuations through time. Next, we'll add on a third data set, which is a measure of total steroid composition.
So points on this figure that are above 65% are indicative of human presence in the watershed. Anything below this 29% threshold is indicative of herbivore populations. And anything in between is indicative of pigs or sort of a more mixed assemblage. So we've got a really interesting story unfolding there. Interestingly, the only time that any of our data points fall in that kind of intermediary zone is during the historic period when human fecal inputs to the lake went up dramatically, but the livestock went up even more, and so it kind of pushed it into that intermediate zone, and we get the introduction of pigs. So we have the kind of evidence of that there. And lastly, we're going to add on the delta nitrogen 15 record. And in this case, we're using it as an indicator of fluctuations in marine derived nutrients. So this has been a documented trend in lake sediment records where there are anadromous fish populations. You get this massive, or you get these changes in an introduction of heightened delta nitrogen 15 values. So what I really want to highlight here is that copper stanol flux is recording what we think it's recording. It's recording people really well. And my favorite part of this entire figure is where you see the lake gets reconnected to its outlet, which means it's all of a sudden reconnected to migratory fish populations, at which time people are poised and ready, they set up fish weirs, and we see a really big increase in copper stanol flux, which is really cool. So it's recording basically the start of this fish weir complex. If we push it beyond that, we basically can see that people were continuously using the Sebasticook watershed all throughout the Archaic period, which is really exciting. Of particular note, and I'm going to go into this in much greater detail in my dissertation because I only have a minute left, is that we see this increase in people during the Susquehanna period. And this is a really important time period in Maine. It's a point of a lot of debate and contention and for what was going on. And we also see this decline here right after the Susquehanna period, which is indicative of a period called the Little Gap. Importantly, we do not see the Little Gap in other records in our, and there's, that will become more important if you come to my other talk. I don't have time to address it now, but basically it's tracking these cultural periods. So we get this change where you have the Susquehanna tradition come in, people sort of apparently leave the area for the first time in the record. And then you get the introduction of the ceramic period right here, which has kind of a synchronous increase during the time the weir was being built. Interestingly, at that time, I'm being told to clam up, which is perfect because our delta nitrogen 15 record basically increases at this point when the Gulf of Maine, was becoming much more productive. I'm sorry, that was really messy. I will do a better job on May 28th. Come to my dissertation. I'll explain to you why this is so cool. But basically, the copper stanol and the lipids are telling us a really interesting story about people. So with that, I'm sorry for being the first one to clam up. Yeah.
Okay, we still have 1 minute for questions. And it's somebody very
I was trying to get out of there, but
please.
yeah, sure.
Before I open the number.
All the work going on environmental DNA now. Is it verified that this indicator indicates people were there that the environmental DNA doesn't go?
You know, I don't think anybody has done like the ADNA. Are you talking about for the whole record?
No, just the periods when you think people were there. I mean, we're basically, does the DNA suggest there were more people?
I don't think anybody has done, nobody's done any ADNA or environmental DNA studies.
Perfect.
Specifically.
Perfect postdoc.
Yeah, I think we've got a little bit of a problem with preservation of ADNA going back in time. I know a couple other students are working on, ADNA and trying to extend it back in time and it's kind of sediments, but it could be really cool. Yeah, yeah.
It would be a very congenial topic to work.
Oh, come on.
It would. Sorry for the whirlwind, everybody, that was a lot.
Okay, cool. I'll take this time to
No,
apologize
no,
to
no, no,
everyone that had lunch and has to re-listen to pretty much the same talk. Feel free to use this as a time to take a nap, or you can listen and maybe learn something new that you missed the first time. It was only last week, to be fair.
Okay. As you already know, our next speaker will be Ali Berry, and she will be presenting the predictors of large icebergs in northwest Greenland.
I'm super excited to share with you all what we've been working on and learning about large icebergs and their predictors in Northwest Greenland. But before we dive into all of that fun stuff, let's talk about why we study icebergs in the first place. So icebergs are not currently accounted for in Earth system models, and that's concerning because both of these things are really important. So if we break this down, looking at icebergs first, we know that icebergs account for up to 50% of the freshwater flux from Greenland tidewater glaciers. And that's what makes icebergs really important, is that they are calving off or breaking off of these tidewater glaciers that are on land, and therefore they can influence sea level rise. And the other most infamous thing about icebergs is their ability to travel and be in the open ocean and get in the way of boats. So this figure here is showing our calving rates around Greenland, and then the ocean currents that take the icebergs out and away and down to places like where the Titanic happened. And not only are they a shipping hazard, as they're moving away from their source, they're constantly melting and injecting their fresh water, which can in turn impact ocean circulation. And so then the other part of this problem statement is our Earth system models. And these are really important because this is what gives us graphs like this, which hopefully all of you at the Climate Change Institute are at least vaguely familiar with. This is the sea level rise projections under the different emission scenarios from the latest IPCC report. And this figure, as well as all the others that are similar to it, are created using these Earth system models for a compilation of these Earth system models. But remember that they don't currently account for icebergs. And so we know that they're super important for these future projections, and they don't include icebergs. And that's because icebergs are kind of hard to measure. They're always moving and melting and flipping over. And so since they're hard to measure, we don't have a whole lot of data on them, which means we can't really inform the models on what they're doing in that way that the models need. So instead, currently what's happening is the models will dump all of this fresh water right at the ice-ocean interface. And in the case of Greenland, which we saw some great figures in earlier talks, they have those really long fjords. So what ends up happening is we get an over-attribution of freshwater flux in the fjords, while kind of simultaneously ignoring those icebergs that are moving out of the fjords and melting in the open ocean. But it's not all bad news, because just because models are bad at icebergs, no fault of their own, they're really good at a bunch of other stuff. Things like atmospheric temperature and sea ice and sea surface temperature and wind speed and glacial velocity, things that we have pretty well constrained. And so we can model them pretty easily. And so this is good news, because icebergs don't exist in a bubble. They're part of this greater complex system here. And so the thought then becomes, well, maybe we could monopolize on these really well modeled and well studied variables to learn something insightful about the icebergs that we see. But before we do that, we have to first kind of get a little bit of grasp on the icebergs. And so we do that by using a machine learning detection algorithm that picks out the icebergs from its background. We do that using Sentinel-1 imagery, so we can get kind of a year-round look at these icebergs and start to break out where they are, how many of them there are, what their volume is, what their different size categories are, so that we can start to fit them into this bigger system here. And so we do that, and I can't tell if this is going to show up really bad or really not. I apologize. This is Greenland.
And we are looking again at the northwest drainage basin in Greenland because it currently has the highest discharge rates compared to the other basins. And then we split this region up into 7 different sections that we see colored here. And then within that, our iceberg distributions are kind of twofold. So we have just fjords, so just like along the coast here, and then we have iceberg distributions out in this offshore water as well. And now we're gonna look at a bunch of histograms, so that's not necessarily fun, but bear with me. The first one we're gonna look at is our just plain old iceberg distribution of the fjords over the time period we're looking at, which is 2020 through 2021. And so again, we're can match these colors to their correlated colors over here. Northwest 1 is furthest north, it's down here. Northwest 7 is furthest south, and it's this pink up here. And then over here, we just have the number of icebergs. So we can start to see some interesting patterns, some seasonal trends and everything. And I probably really want to highlight that we see that regions like Northwest 2 in orange and Northwest 7 in pink kind of have the highest amount of icebergs in comparison to say Northwest 6 and Northwest 5. But this is just kind of the first glance at it. The other thing we want to do is look at what the breakdown of these icebergs are, like how many of them are small, how many of them are large, because again, the way the models are working right now, just assuming that it's all happening in the fjord, we want to assess how good or not good that assumption is. With the thought being that it's these large icebergs that are going to have the capacity and the volume to make it offshore and into the open ocean. And so when we break this distribution down into small and large categories, we get something that looks like this. There's a pretty clear pattern here, if you want to call it a pattern, where we have blue here is representative of small icebergs and just large icebergs. And it comes out to 89% of the icebergs in this distribution are what we consider small icebergs. So now you're probably like, well, then it seems like what the models are doing aren't that bad after all. So many of them are small and presumably just existing in the fjords and melting there and not making it out into the open ocean. But that would be a boring story, so that's not the case. So if we change this here to be volume of icebergs rather than number of icebergs, we get almost a complete flip in the trends where we see that the large icebergs account for 82% of the total volume. So even though there's so few of them, they're making up such a large percentage of the volume. And it's that freshwater flux that's getting injected into the open ocean that the models are missing and that we're really interested in. And so the other component then is looking at the difference between what's going on in the fjord and what's going offshore. And if we do that, we're going to look at another histogram like the first one. But this time for our offshore region, the most important thing to take home here is that this number is now in the millions rather than the hundreds of thousands. But again, we're still just looking at our different regions here and the number of iceberg that's in each region. And so if we compare these two distribution graphs side by side of our fjord and our offshore, we can see that these do not directly correlate. So again, negating in the situation where the model's current route is probably not the best one. What's happening in the fjord is not directly translating to what's happening offshore. So even though we have a lot of icebergs in this Northwest 2 region and Northwest 7 region, in the fjords, those are not correlating to what's happening directly offshore from them. And so now we have our iceberg distribution part, or at least some of it, which is really great. And then with the help of others, I was able to compile all of this data here with all of these variables, or what we'll call features. And then we're able to use these features along with our iceberg distribution and run what is called a random forest regression analysis, which I'm not going to get into the details of, but would be happy to talk about later. But basically what it does is it takes all of these features, we have glacier dynamics, atmospheric conditions, oceanic conditions, and then it runs a model where a bunch of decision trees are made and compares it to one of these iceberg distribution metrics. And so what we can say then is, oh, okay, well, if we can determine what is able to predict an iceberg abundance, then we could use that variable in the models to inform what the icebergs are doing. And so for an example, some preliminary results, if we look at the results from our random forest regression that we run for the volume of large icebergs, we get something that looks like this. Where again, we just have our 7 regions here with Northwest 1, the furthest north on the bottom. And then the different colors represent the different features or environmental variables that we are comparing our distribution to. And the thing I want to highlight, which I know these colors aren't great, and that's kind of on purpose, is that when we're looking at these northern regions, CA's concentration is the dominant predictor. And as we move further south, glacier velocity becomes the dominant predictor. So we're starting to get some interesting results. But I guess you could say it's just the tip of the iceberg. You have to mention the Titanic tip of the iceberg. So just like our distribution is pretty cool, our random forest regression should be pretty cool as well. So far we're going down to the fjords. We need to look at that offshore as well, so we can make those comparisons. The other thing that we're working on right now is doing a time step for this random forest. So right now we're just comparing it same date to same date. But naturally, we could probably all imagine that the temperature a few weeks prior might be influencing the icebergs more. So running some sensitivity analysis to best fit those. And then also doing some deeper statistical analysis to get what those relationships are. And with that, thanks to everybody who's contributed. I'll take any questions.
There is any question? Please.
So you show that figure that shows the disparity between the number of icebergs near the fjord and number of icebergs offshore, and then you also showed that the number of icebergs that are small much outweigh the ones that are large, but the ones that are large are the ones that most likely matter. So do you know or have an idea of how many of those large ones are actually involved in that millions of icebergs that make it offshore?
That's a great question. We don't. That was originally what our lake hope was to get at kind of an attrition rate from fjord to offshore. But as you remember, the fjord one had like hundreds of thousands of icebergs and the offshore had millions. And so presumably what's happening is that icebergs from other regions are getting into those currents. And so it's hard to get at an exact attrition rate. And this comes down to, again, like the issue of icebergs being kind of hard to measure directly. It's kind of hard to like track it from one place to another because it's constantly melting. So that's unfortunately not the goal of this project, but is super important as well. So we do not know what exactly the rate is.
One more question.
Is there a longer time series from Sentinel available, or it's just that 2 years?
So for the fjords, there's a longer one. It spans back to 2017, but in the offshore, we are constrained to 2020 through 2021. And it's not a Sentinel issue, it's a processing issue that we're running. So those iceberg distributions are actually done by some colleagues at the University of Kansas. So they have limited data capacity for getting those distributions done.
And does it require 2 timelines to do this, or just once?
I think just one.
Okay, thank you very much. Well, our next presenters will be Suman Acharya, and he will be presenting the Nepalese multi-level governance system and analyzing the power and politics in climate adaptation governance.
Right. Thanks, Lucy.
Please.
I'm presenting one of my dissertation chapters here. Like it, I'm just gonna defend my dissertation in 16 days from today. So it's a good platform sharing my one of the chapters here. So I'm gonna talk about how the climate adaptation is politicized. So I'm gonna take a case from Nepal and present that here. So it's gonna be a lot of photo stories today and some social stories. Yeah, my title is Nepal's multi-level governance system, analyzing power and politics in climate adaptation governance. Okay, this is going to be my outline. So I'm going to start with introduction and finalize with my conclusions with some results and methods. So a brief introduction. We know the climate change is undeniable fact. I just talk about this all the time because we have a lot of climate deniers, and I just want to talk about the undeniable fact about climate change. So we have science, we have stories from the communities, and we have other sources of knowledge that argues that climate change is real. So climate change is both socio-political, climate change challenges both socio-political and the ecological system. So we have the social stories that are impacted from the climate change, we have ecological systems, and the stories from the ecological background that is impacted from the climate change. And adaptation is the political phenomenon. So we have different forms of scientists talking about adaptation. We have the adaptation from the biophysical sciences and also the adaptation from the socio-political background. So in this research, I'm going to talk adaptation as a political phenomenon. I'm going to talk about this in my research section a bit more. So continuing the introduction, there remains always a power. So as I talk, adaptation is a political phenomenon. There is a power in politics within the adaptation governance system that determines the success or the failure of the adaptation. The socio-political or the economic inequalities at the multiple scale results the power in politics within climate change adaptation. So here are some pictures. I mean, these are cartoons, but they give a lot of pictures about how climate change is happening, and some socio-political stories on these pictures. So climate change is a threat multiplier. So one thing is climate change is not like a very, I mean, it's a new thing, but how is it created? Sometimes it's the social and the political factor that advances the climate change and the threats of that climate change impacts. That's what I'm going to talk about that here. And also the climate change increases the vulnerability and challenges adaptation, which is fairly true. So now briefly talking about the framework that I'm using for my analysis. So it's the multi-level governance framework. So this is the framework that I took, from the Hall et al. 2017. So defining the multi-level governance is the, so I'm just going to read the definition from the JACNI that I took from the paper. So is the mutually dependent relationships, be the vertical, horizontal, or network among public actors situated at the different level of governance. So we can see here, this framework shows how the multi-level governance is happening. So this is kind of an ideal type of governance system where the vertical and the horizontal governance system is balanced. The vertical governance relates to the hierarchy of the government. For example, the federal government, the province, and the local government in my case, and the relationship between them. Similarly, the horizontal governance is the cooperation between other partners horizontally. So power and politics are inseparable within the across the multiple governance system. So power and politics determine how the adaptation governance is happening within this framework. And I'm going to clear this thing from my result. So I'm going to see how power and politics interact with the authority, knowledge, and resources within this system. So knowledge, authority, and resources, these are the topic of the power and politics, because whenever we talk about authority or whenever we talk about the knowledge or what kind of resources are required for the adaptation, these become the topic of the politics. So continuing forward, so this is the study area. So it's Nepal, so one of the most climate vulnerable countries. And within Nepal, I chose the Karnali region. So this region is the most rural and the vulnerable part of Nepal. So they have like very low adaptive capacity, whatever. And so most of the people here are dependent on agriculture and wage labor. So they are more vulnerable in this region. And also from the biophysical climate science, this region faces a lot of climate hazards every year. So this is my methodology. So it's more based on the qualitative research, including the participant observation. I did some oral histories with the old farmers. I did the household interview in the 3 communities from the Karnali region. I also did 3 focus group discussions to support my study. And finally, I used the NVivo for analyzing my qualitative data or coding my data, qualitative data and analyzing those. So coming to the results section, so I have here, so whenever we talk about climate change, we know that the biophysical science or the climate, the biophysical hazards are, of course, the impact of climate change. But sometimes so from my result, what I see is that these social or the political factors that determine the climate change adaptation are really missing within this framework. I mean, there are a lot of things happening at this time, which I acknowledge, but however, from my research, I found that how the local context or how the social political context of the locality matters to climate change impacts, or how does it matter to adaptation for addressing the climate change, and also for preparing the climate change policies and programs. So these things I really find missing within this. And okay, yeah, to support that, I have one quote, the quotation from my study. I'm going to read it loud. In our context, the understanding of adaptation is popular in the climate change sector only. However, I would say that climate change is only an aspect where adaptation is not only the aspect where adaptation works. There are several other areas such as social, political, and economic aspects where adaptation should work equally. Climate change is a new problem for us. However, the social and political problems that existed for generations are still prevailing, which increase the vulnerability of marginalized communities. We should think about these aspects of adaptation as well to secure reduced social, political, and economic vulnerability. So this is the story that I collected from the province, the Cornell province, and coming into the major part of my research. So what I found here is like the most of the the decision-making authority and the resources, for example, the finance resources that are generated from the international forums or other kind of resources and the knowledge there that have been collected from the international forums, they are located within the federal government system, at the federal government. However, the authority to making the decision while making the policies and programs, they are not they are not decentralized to the state and government, to the local government. I found the low coordination between these government system that has really impacted the climate change adaptation policies and projects. And at the state and local level, so I don't. In my reasons, I see the very weak collaboration between the other stakeholders that are working within climate change adaptation. Due to this, the climate vulnerability of this region is highly increasing. So this is the next story that supports my result. So I'm going to read one more loud. So I feel that while making plans, policies, and acts at the federal level, we are still unable to secure the meaningful participation of local and provincial governments. If the participation was secured, they would have multiple queries and concerns regarding plans and policies. So this shows that how the federal government, despite having a decentralized system, despite having a democratic system, the federal government have been following the centralized system, due to which the adaptation problems are not addressed. So concluding remarks. So I found that adaptation is treated as a political process, whether I argue that it's a political process. Authority, knowledge, and resources are centralized at the federal system, despite having a democratic political system. These are more donor-driven based on how the donors treat all these things. And I see that this challenges the multi-level governance system, where, however, I recommend that the multi-level governance system is a good system where the authority and everything should be more decentralized. Thanks. And these are all the acknowledgements.
We have 1 minute for question.
Yeah. Sure. I have a question about how you measure or think about adaptive capacity. And what do you think is adaptive capacity at the local level? And do you see any capacity building like programs for the local level?
Yeah, thanks. So for this, I mean, in this project, yeah, there are different, NGOs and the government projects and also the INGOs, they are working in that areas to help them build the adaptation of the communities. So how I define adaptation capacity here for this project is like how they are, how these programs are helping those people to enhance their, livelihood at the same time, how they, how they help them to fight the climate change. I mean, yeah, so that way I try to define that efficacy. Yeah.
Okay, thank you very much. And so our last speaker for this session, Jasmine Zaros, and she will be presenting abrupt transformation of the West Greenland lakes following compound climate extremes in September 2022.
Thank you. Great, well, I just wanted to share some new results from my group. And this is a collaboration with Bendy, Avery, Grayson, Sean, and also Robert Northington, who's now at Elizabethtown College in Pennsylvania.
That's first one, okay.
So I've been monitoring a suite of lakes in West Greenland for the last decade. And we've had a number of different projects going on in this area over that time, but we've made a point of continually monitoring a set of lakes for a suite of parameters over this time frame. And so you can see we've been going basically in the summertime most of the years, and then with Bendy's PhD work, we decided to add some under ice sampling, and so we extended our monitoring to that time period as well. So in April, you can see Bendy there working on the ice, drilling through to sample the lakes. So overall, we've had 16 expeditions to this area, including 3 last year, and we'll be going again this year. And these lakes are an example of systems that have limited hydrologic connectivity, which means that they get actually very little inflow, so very little contribution from the landscape typically. And they're strongly influenced then by evaporation. There's fairly little precipitation here, and we tend to get fairly little to no overflow from these systems. And this is representative of about 25% of the lakes across the Arctic. So it's a good example of many lakes that we find in the Arctic. This is what they looked like before 2023. So they were what we call blue lakes. So they're low productivity, very clear systems, and they look blue, so we call them blue. And then in 2023, they all looked like this. So they were completely transformed in 20. It was a nice slide. So in 2023, they all took on this very dark green. So this wasn't just 1 lake or 2 lakes, it was all of the lakes that we sample, and you can see this as well more broadly across the landscape. So they went from being what we call blue to being brown. And this is actually an important paradigm in lake ecology. When we think about how productive lakes are and what drives that productivity, we plot them out in this space based on a couple different variables here. They plot out in blue or brown. There's a couple other categories that we won't look at today. But you can just see that, again, the 2023 samples basically migrated up into the brown zone. So what causes browning? What contributes to browning in these systems, or in any lake systems? So there's actually 2 primary materials that we think about when we're talking about lake browning. One is dissolved organic carbon. And so in the flasks here, we're seeing increasing dissolved organic carbon as you move up in the color. That's basically natural material, comes from, most of the time comes from the landscape, from plants and bacteria. Breaking down organic material, we get this dissolved organic carbon that can come into systems. We also know that metals such as iron can contribute color to lake ecosystems as well. So with increasing iron concentrations, we get a darker brownish red stain. Broadly, in the Northern Hemisphere, we've seen gradual changes in dissolved organic carbon and in iron. So we've been seeing increases in many lakes. It's a very gradual change, and often not something you can see with the naked eye. It's something we detect by doing the chemical measurements. And that's what these plots are just showing here. In many lakes, we've seen an increase in DOC, the dissolved organic carbon, and also in metals. But at the same time that we've seen an increase in some, we've seen a decrease in others. So not always a coherent sort of change across the landscape. So the 2023 change in West Greenland is unique. It's an example of an abrupt, coherent, strong browning event. And we saw these lake ecosystems transformed in less than a year. So we can take a look at some of the chemistry of these systems to see exactly what changed here. We can look at that dissolved organic carbon. We see that it increased 22%, but these lakes always have high dissolved organic carbon. Most of the time, that dissolved organic carbon is actually very low in color. So I should mention the blue dots are all the pre-2023 and the brown is for the brown year. The SUVA 254, that's an indicator of the quality of that DOC. It is a signature of soil-derived organic carbon, and it imparts color often in aquatic systems. That increased 39% across our lakes. And I should mention each of these points is representing what we're seeing across the 10 lakes in each case. And then we also saw iron concentrations actually increase by 1,000% across these lake systems. So a number of different factors here increase that can contribute to this brown color. We think that this lake chemistry changed because of greater terrestrial inputs. And so our evidence for that is that if we look at the percent difference in these metrics compared to the watershed area to lake area, we see a trend where the bigger the watershed relative to the lake, the more of a change that we saw in these systems. We can also look at some of the characteristics of the dissolved organic carbon. We look at the molecular weight and the aromaticity, just two signatures basically of that material. And if we compare two lakes, we only have data from 2 lakes before 2023 for this. If we compare where they were in the blue compared to where they are with the brown dots, we see they're migrating to be more similar to samples directly collected off of the watershed. So again, some signs that this is coming from the terrestrial environment. We think there's not much evidence that there was a change in internal cycling in these lakes, because you can see changes in the chemistry of lakes because there are changes in internal cycling and interaction with the sediments. And dissolved oxygen concentrations are often a key metric that would control or change that internal cycling. And we actually didn't see any change in dissolved oxygen concentrations. So why was there an increase in terrestrial inputs here? So if we take a look at just generally the landscape here in 2014 compared to 2023, we had a very dry landscape. You know, as I mentioned, we had lakes that had limited hydrologic connectivity. And then in 2023, the landscape was literally just saturated. There was flowing water in places we had never seen flowing water before. The water isotopes from these systems further underscore the change in hydrology that happened here. If you look at the plot on the right, we can see that in 2023, the water isotopes migrated closer to the meteoric water line, which means we saw reduced evaporation in 2023 compared to 2022. We can break this down further on the left, and the bottom line with what we're seeing on the left here is that that shift in hydrology happened sometime between August 2022 and April 2023. So it happened at some point after August, but before April. And so a big question for us then was, what happened during that time? And this is what happened in the autumn of 2022. So you can see 2 plots here. We're looking at temperature, the standard anomaly, looking at September 2022 compared to 1951 to 2000, and the asterisk shows where our study sites are. And you're seeing the precipitable water on the right-hand side there. So you can see basically what happened here. There was a series of atmospheric rivers that hit this region and led to this remarkable change here. This led to record precipitation and heat during the month of September 2022. It actually persisted into October as well, but I'm just focusing on the September data here. So you can see going back to 1940, the record heat and precipitation in this area. And I will say last summer then continued this trend as well, where even after we did our first sampling,
then the month after that was also remarkably wet, and so just kept propagating this effect. There are a number of ecological consequences of this browning. So we can look at the vertical habitat gradients, which are really important in lakes. So if you imagine the top of this plot is the surface of the lake and we're moving down into it, the position of the maximum chlorophyll change, that's where all the phytoplankton are. That's the food for the rest of the food chain. And we saw that chlorophyll max moved from the deeper part of the water column up to near the surface. And this plot is just summarizing that for every single lake, showing how pre it was down deep and post. So in 2023 ends up higher up in the water column. We also saw a change in the phytoplankton species here. So we saw a change from species that primarily take up CO2 as their carbon source to those that take up CO2, but also rely quite a bit on organic carbon in the water column. And we saw an increase in zooplankton diversity. So those are the animal plankton that we see in these systems. And we saw an increase in diversity, possibly because of the rotifers, which is a group that uses bacteria and organic carbon sources. There actually are no fish in these systems, so they're the top of the food chain. Importantly, these lakes switch from being summer sinks to sources of CO2. So we have data from the ice off period, basically the April sampling period, that shows no difference really in terms of the CO2 flux at that time. But in the summertime, between 2022 and 2023, there was a 354% increase in the CO2 flux from these lakes because of this browning event. Methane concentrations seemed higher. They're not statistically significant, but who knows what will happen going forward. So just to summarize, we saw that these compound climate extreme events in autumn 2022 triggered this widespread browning event that transformed these lake ecosystems. We saw numerous ecological implications of this transformation. One important outcome of this is the switch from these lakes in the summertime from being sinks to being sources of CO2 across the landscape. And our next steps are to assess the trajectory of these systems and to think about how long will this transformation last? Have the lakes entered a new state? And what is the legacy of this transformation? So with 16 expeditions, we have a lot of funding sources to thank for supporting our work there. Mike, Scott, Tamara, and Cap for all the lab analyses they've done over the years, and many, many people who have contributed to the field assistance. So thank you.
Yeah, I was wondering if this is really terrifying and interesting. I was wondering if there's any interest in getting some paleo data to see if these switches have happened in the past or if this is a completely novel event.
So we did take some sediment cores to start by looking at just the very surface layers to see, we were looking at a number of different metrics actually, like what happened with pigments, diatoms, eDNA, and to compare that to just like the next slice down. So we haven't found too much of that yet, but we are trying to see if there might be some signatures there that then we could apply further down core. So, yeah.
I was really interested in your discussion at the end of thinking about future trajectories for this system and whether or not a regime change has happened.
Yeah.
And I'm wondering what kind of factors in these lakes would render them more resilient to be able to bounce back in an extreme circumstance like this, rather than enter a new state.
Yeah. So it very much depends on what the precipitation is like going forward. I would say, well, precipitation and heat going forward, but primarily the precipitation. If we see a reversion back to drier conditions and the lakes once again become more isolated from the terrestrial inputs, then it's a matter of time in terms of how quickly does that influx of material that we saw precipitate out, bleach out, those types of things, and eventually be lost. It could actually be quite rapid, but we're not sure at this point. So we will be going back this year to examine that a bit more.
Okay, thank you. That's me.
The David Clayton Smith lecture. How many of you were here when Dave was still a member of with us and a member? How many of you weren't but have heard of David Smith? How many of you don't have any idea who he is? Okay. David Smith was one of the founding members of the Institute. He was a historian, a pioneering climate historian, among many other things. He wrote a book that was nominated for Pulitzer, which was a biography of H.G. Wells. And the guy did everything. Whatever you asked him, he had an answer for it. Whether true or not, I don't know. But he always knew the answer to everything. He had a great sense of humor. He was a punter, which I greatly appreciated. And when he passed away, the Institute created the David Clayton Smith Lecture in his memory. And I'm very pleased today to introduce our speakers. We have co-speakers today, Cindy Eisenhower, Professor of Anthropology and Climate Change, and Nick Basinski, Assistant Professor of Political Science and International Affairs. And they're going to talk about taking stock of climate progress at the COP, challenges and opportunities in international climate governance. I'll just mention that I only do punning summaries for graduate students.
Thank you very much. It's so exciting to be here today. The Bourne Symposium is excellent. It's great to see the grad students and everyone else that's research. Today I'm going to talk today a little bit about the University of Maine's delegation to the climate conference, UN Climate Conference. If you don't know about it yet, every year we take a group of students and faculty. You're invited to apply. The deadline is April 15th, so please apply. If you need information, get a hold of us. But we take students who are doing both research and policy advocacy, others who are doing some sort of engagement, and there's a lot of diverse ways to participate. So just a quick outline of what we're going to talk about today. We're going to go over the general background of the UNFCCC and the COP process, some of the basics about what happened at COP28 this year, and then move to what Cindy's research agenda has mainly been, which is in the global stocktake, and then where my research agenda has been at the COP, which is on the African group and the loss and damage fund. And then we'll wrap up with some conclusion and a general reflection. So my background is on UN processes and global governance, and I teach a class called the Global Governance of Climate Change. Again, if you haven't taken the course, it's this fall. I highly recommend any climate policy students, anyone interested, it's in the fall, and you're more than welcome to take it. What we study is the process of how the UN and all states interact, negotiate on how to cooperate together to address climate change, right? And the real basis for that is the 1992 UN Framework Convention on Climate Change, that's the Rio Convention, which set out the rules in which states would negotiate, right? The main way about that they do this is once a year, they come together and negotiate at the COP, which is the Conference of Parties, right? It's usually in November or December every year, and every state in the world comes as negotiators. There are also many observing parties that were observers, along with civil society actors, youth organizations, groups from around the world that are able to observe and try to influence the negotiations. But only states are the ones who get to vote, of course, and they're the ones who are trying to influence here. They're the annual conferences, as I explained, and the big annual conference, you may remember Kyoto. Kyoto was a COP, came out of the agreement, was one of the agreements that came out of the conference. The Paris Agreement was also a COP, and it's now one of the governing frameworks in which every year we check in on the goals and the sort of nationally determined contributions which they set at the Paris Agreement, right? You'll hear much more about that in Cindy's portion. And so COP28 was in Dubai this year. We took a group of 8 people from University of Maine, split between 2 weeks in November and December. There were over 100,000 participants, and that's the most participants they've ever had at a COP, in part because it was sort of ramping up after COVID, where they didn't have a COP, and also because the UAE was hosting it at this gigantic center and were able to facilitate participation. It was also somewhat controversial because it was being hosted by an oil state. And in fact, the host, the president of the COP, was the Sultan Al Jaber, who is the CEO of the Abu Dhabi National Oil Company. So there were some tensions over how neutral and arbiter they were. And we're going to go into some of the headline major accomplishments for COP28, but that's in the next bit. So I'll now hand it over to Cindy, and we'll move to the next section.
Okay. Thanks to all. I just want to set a timer for myself.
Okay, so COP20, each COP is a little bit different in that they have different outcomes based on what is on the negotiating agenda. And so many of you may know that this last COP was really important because it was the conclusion of the first ever global stocktake. So the stocktake and some of the big headlines to come out of that, right? We have some targets to triple renewable energy. We have some targets to double energy efficiency, but also the big outtake was that we're going to transition away from fossil fuels. So some big headlines to come out. But what's most important, I think, to note for this group is that the function of the GST, it is the central ratchet mechanism of the Paris Agreement. What it's designed to do is to increase ambition over time so that we get to that climate neutrality by 2050. So in thinking about my research, though, I want to just point to the actual text of the article and note that the global stocktake is mandated, and all parties agreed to this, that it must be conducted in light of equity and the best available science. So my research, which has been ongoing for quite some time at the negotiations, was to examine how does this get operationalized? How do we conduct the first global stocktake to see how we're doing in reaching the Paris Agreement, the goals of the Paris Agreement? How do we do that in light of equity, and how do we do that in light of the best available science? So I was particularly interested in how parties understood those two terms, how they tried to operationalize them, and how they were eventually reflected in the end, the final text of the GST. So in order to get you there, let me just first give you some background that's really important. So the Paris Agreement really marked a huge shift in the international climate regime. So a lot of people celebrated it as groundbreaking because for the first time ever, all countries would be subject to legally binding mitigation targets. So rather than what was true under the Kyoto Protocol, where we had a staged kind of rollout of mitigation targets that was based on this idea of common but differentiated responsibilities and respective capacities. That required the developed countries to act first because they had been responsible for the historical cumulative emissions in our atmosphere with long resident times, as you all know. This shifted it so that instead all countries would put forward nationally determined contributions, or NDCs, which are basically like voluntary pledges. So that's what's legally binding, right? But each country gets to decide based on their own sovereignty what is an appropriate mitigation target for them. The critiques are that this kind of shift in the Paris Agreement undermined any sort of a concern with equity and justice. So it allowed that to become very ambiguous. It prioritized political feasibility over effective climate action, and it reflected the interests of the powerful countries. This was pushed for by the United States primarily to move toward the system. So many scholars, including myself and our former student Anna McGinn, have argued that Paris really marked a shift in the normative structure of the international climate regime from one based on distributive justice, right, where the developed countries act first, to one based on liberal notions of justice that are about mutual advantage. So these concerns were actually well-founded. When the NDCs were put forward, parties were supposed to say how their contributions were equitable. And a study of 122 different NDCs showed that only a handful of parties even mentioned equity in their NDCs. And as a result, what we get is this huge mitigation emissions gap, right? So we can see here, 2010 policies, current policy scenarios, and where we actually need to be for a 1.5 degree Paris target. So huge mitigation gap. So a lot of people were really, really hopeful that the first GST would show us this big mitigation gap, and that it would reintegrate some concerns about equity, right? So because Paris kind of left equity behind, the GST was seen as the moment where we can actually revisit equity and try to, make sure that people are ratcheting their ambition. And part of the key aspect of this is that it's the whole design of the GST is based on what they're calling a virtuous cycle, where we see that other parties are doing their fair share, and we trust that they're actually doing it, and that therefore we feel confident upping our ambition as well. So the first GST was supposed to inform the next round of nationally determined contributions, which come in next year. So with all this concern about how is equity going to be included, there is a lot of climate science out there, right? Lots of accounting frameworks, which are able to integrate equity into how we think about allocating mitigation burden. So just a really quick overview of some of the science, but you can do it in multiple ways, right? You can do it based on equality, and this is just basically fair shares, right? On a per population basis, you can do it based on need, so the right to development, and that's usually based on some sort of a human development index. You can do it based on capacity, so how much capacity do countries have to increase their mitigation burden, usually based on GDP, no surprise there. Or you can do it on responsibility, and that has to do with the degree to which the party caused the problem in the first place, right? And that's usually based on historical cumulative emissions or per capita emissions. The science is out there, and there are even composite indexes that pull all these together that can tell nations like what would be a fair share for you based on these indexes. So the science is there. So what did I do? So very quickly, I've been attending the COPs and coding all text and informal notes since Paris. So since this was decided, I have coded all party submissions to the first global stock take. So 54 submissions from parties or groups of parties. I've also been in the room and typing at an incredibly fast speed. You wouldn't believe how fast I can type to kind of build transcripts of the actual negotiations themselves, totaling 53 days of observation over quite a long period of time. So yeah. And one thing to note is that while equity is cross-cutting across adaptation, means of implementation and support, I'm really focused here on the mitigation space based on my long-term research interests. So quick kind of statistical, just descriptive stuff. In the 54 written submissions, equity is mentioned 434 times. Lots of parties and groups of parties really interested in it, but we see interesting patterns when we start to break that down to see who's talking about it and in what way. So you can see, for example, India, Saudi Arabia, Pakistan for G77 and China mentioning equity a lot. And when we look at their notions of equity, they are almost always talking about responsibility for need, right? So the idea that wealthy nations should be doing more, and those countries who are underdeveloped need the carbon space to develop, right? And it's essential to their well-being. Meanwhile, developing countries, US, Canada, EIG, Environmental Integrity Group, and Australia, very few mentions. And when they do mention, they tend to talk about it in terms of universal action. They'll say things like, the only fair outcome is reaching 1.5. So no differentiation at all. Or they're talking about internal, like domestic just transitions. So just transitions for historically disenfranchised groups in their own countries. So one thing to note is that developed status is the most reliable predictor of which equity considerations folks use. But contrary to a lot of assumptions, this work also validates previous research, which suggests that people are not necessarily relying on equity indicators that would advantage them. So there's not a clear relationship between somebody saying, well, you should work on capacity because that would give them a smaller mitigation burden. Okay, so I want to get a little controversial here in a room full of scientists and just give you a really quick overview of some of the interesting things that I've heard about the role of science in this process. So the IPCC did, for the first time in AR6, put out some data on historical cumulative emissions in the report, which definitely shows that North America, Europe, some of the most developed countries, do have a bigger contribution to climate change on a per capita basis or just a historical basis. However, a lot of parties were really upset about the IPCC's engagement with equity in terms of the pathways and scenarios that they put forward. So the IPCC actually recognizes this in the Working Group 3 report. They say a wide range of global emissions pathways and scenarios from the literature is assessed, but most do not make assumptions about global equity, environmental justice, or interregional income distribution. The reason why they say is because it's complicated to take equity into account. There isn't one universally accepted notion, and that countries might strategically choose the criteria that favors them. So they say, instead, we're not going to address this, we're neutral. Well, as you can probably imagine, and I don't expect you all to read this, but in case you want to, it's there. As you can probably imagine, a lot of developing country parties came back and said, your refusal to engage with the science on equity is a political act. And by putting forward scenarios that assume inequality is going to persist into 2050, you're locking in that poverty. And you are very much engaging in a political act. So Zambia, for the African Group of Negotiators, actually called for the GST to document this and to communicate it to the CMA, which is the Paris Agreement, and to the IPCC. Saudi Arabia said, that's then my time, I gotta turn it over to Nick. Saudi Arabia said this creates a discussion where equity and science are pitted against each other. And India said you can't tell a developing country that you're going to remain at low levels of income. Equity considerations cannot be outside these scenarios. This does not consider past emissions or a right to a fair share of the carbon budget. I have one more minute. So how does this all relate? And I thought I'd just give you one example of how does this all translate actually into the negotiation of these texts. So we've got people that are really upset about this idea that like, there's no accounting for historical emissions. There's no accounting for this fossil fuel induced development for some and taking away of mitigation rights to others. And how this often translates is in the actual text itself. So as they were negotiating the fossil fuel phase down, we have 4 different texts that came out throughout the period of the COP. The first one had the text read an orderly and just phase out of fossil fuels. On December 8th, that was all strict, and it was all about a phase out responsive to science. That was, you would think that the conference was going to explode. Developed countries did not like all of that. So on December 11th, they came to a compromise where the text gave a laundry list of options that could include. And the most vulnerable countries really reacted negatively to that. And in the end, we did get somewhat of a compromise, transition away from fossil fuels in a just, orderly, and equitable manner that is not operationalized at all. No way to track it. Accelerating action in this critical decade so as to achieve net zero by 2050 in keeping with the science. So that's where we ended up. So that's a brief overview of the stock take. We'll come back to it in a minute, but first Nick is going to tell us about the loss and damage fund, which was the other big headline to come out of the top.
Well, and it's also a great transition from the global stock take to my work because the role of the African group is really important, I think, in a global stocktake and in the next step of the loss and damage. So my research at the COP is following how African countries negotiate and what their participation in the COPs has been over the last decades. So that has included both statistically looking at the number of submissions, the number of delegates they send, the way in which they participate, and then doing participant interviews with negotiators at the COP. So one of the things that we see as a top headline is that there was more participation of African delegations than ever before. They were also were essential for the landmark agreement on the loss and damage fund, which I'll talk about in just a minute. And there was a big showing of the African delegations in all parts of the negotiation, the global stocktake to other parts as well, right? So the loss and damage fund, it's been part of the negotiations for years. Developing countries have wanted, in addition to mitigation and adaptation, to be negotiating on loss and damage, which is the idea that climate change is already happening, it's already creating damage, and so states should be compensated for that, right? Not to mitigate, not to adapt, but to be compensated for what's already been damaged, right? There's an essential justice argument to that, that the countries that are most affected by that, of course, are those who are not usually the ones that have polluted. But within some of the negotiating platforms before and former agreements, they have explicitly said that any sort of discussion of loss and damage cannot be compensation by rich countries, right? So it has to be some other version of it. And a lot of the discussion outside of the negotiating rooms is about this compensation, but that's a real disjunct between what the actual negotiators talk about. The decision last year in 2000, the one in Egypt, COP 27, they officially agreed to create a loss and damage fund, but they didn't operationalize it or put any money in it. The first day of the COP this year, they operationalized it, so created that bank account, and then started to have pledges for it, right, which is a big accomplishment. We thought it was going to take the whole week or several weeks to get that through, but it was the first day that it happened. Right? They agreed that it would be hosted by the World Bank, which is also a little controversial. They wanted a separate one that wouldn't be controlled by developed countries, right? The rich countries control the World Bank. Well, if it was outside of the World Bank, then maybe developing countries, poorer countries would have more influence. They didn't get that agreement, in part because it's very hard to set up a fund out of nowhere, right? The logistics of that are very difficult. So the World Bank is going to host it, but they have a governing board of 14 developing countries and 12 developed countries, which means developing countries have more influence. And by the end of the 2 weeks, they had 730 million voluntary pledges, right? So this is also important. It's not a mandatory fund. It's not done by taxes or dues. The voluntary part of the Paris agreements, it's continued into this fund, right? So states pledge voluntarily. We don't know if they're actually going to donate. We have to follow up to see if they actually do. But for example, the UAE, the host of COP28, pledged 100 million. Germany promised another 100 million. France and Italy both promised 100 million euros, and the US put 17 million. You can see where our politics of at least the negotiators lay. They are not in favor of the loss and damage fund. They did promise $3 billion for the adaptation fund, right, which is a separate bit and will fund different things. But the US, the government is very much against this type of funding. Right? They support it in principle, but won't put money behind it. And the way in which the fund will be distributed, it can be through direct access through governments. They can either have projects or have budgetary funding. They can get subnational, so it doesn't have to be the federal government. It could have subnational. So this connects with the previous presentation about Nepal, that the subnational governments could apply for funding there. And communities, so civil society groups could apply as well. But we don't have any grounds for how they're going to select the projects or which ones will be prioritized. There are, of course, a lot missing on the loss and damage fund. Here you can see that the scale of funding, 700 million, it's pennies in comparison to what's needed. Some estimates say that $400 billion are needed every year for loss and damage. And right now we only have a 730 million, right? The scale is just not the same. You can't build even a dam with 700 million. And they're thinking about funding how many dams being rebuilt around the world, right? Very hard to know what they're going to use this money for. They also didn't have mandatory contributions. Like we said before, it's only voluntary. They could have put in place something like debt cancellation, dues, a global tax. None of that was put on the table, right? So in some ways, creating the fund and making it voluntary was a political step to sidestep any sort of universal participation in the contribution side. And the last is that the governance of it doesn't have any civil society participation. So on the governing board, it's going to be all governments. And so we expect that many of them will be state-centric actions. So I'm presenting some of my research about how Africa participates, in part because this looks like a very successful win for the African delegations, right? They were very much in favor of the loss and damage. And after several years of increased capacity, they hosted a COP in Africa and in Egypt, right? And have led some of the major negotiations. Is this because the African delegation was so strong? And this is the answer is really a maybe right now. So the African delegations discuss and decide their points at COP in 3 tiers. They start off through the African Union. This is a conference that held at the African Union level, where heads of state discuss priorities earlier in the year. Later on, it's at the ministerial level. So those are ministers of the environment who hold another conference to set priorities for COP. So that just happened recently. And then later in the summer, there'll be the African group of negotiators who put out negotiating points and have a statement, which then they, I mean, we don't get to look at it, but all of the African delegations get to look at it before they go into the COP. At the COP, they have daily meetings, which are closed doors that only African delegations can go into, and they coordinate their positions on it, right? There are also African AGN, African Group of Negotiator representatives, who are sort of the lead negotiators who speak for the larger group in the rest of the meetings as well. So there are both individual countries that speak up. So South Africa often speaks up, often in opposition to the US, and the AGN, which is sort of speaking for the larger group. This is the flowchart, which I'm not going to go to, but it's quite complicated. And if you've ever worked in African bureaucracies, this is very typical. It takes a long time to make decisions, and everyone wants to have a title so that they can have influence over something. But by the end, you get to the COP right there. So we charted the number of participants over the last 20 years. You can see the blue group, the light blue are African delegations. The dark blue are the EU. The orange are the group of 77, the purple are OPEC, and the light purple are SIDS, and then other umbrella groups. So you can see how all of the delegations have grown, right? But the African delegation has grown more than all the others, okay? It's up 325%. The only other largest group that grew in that same amount was the EU, that went up by 88%. So we see at least the capacity, the number of people coming to the delegation or coming to the conferences has increased a lot. I will tell you, some of those delegations have, let's see, hundreds of them. So in 2 years ago in COP27, Kenya had 348. This last year, Nigeria had 1,000 delegates. Not all of those delegates are in the room actually negotiating. Some of them are spouses going shopping. That is a phenomenon, not just for African delegations, that's for many people in the world. And in fact, even US delegations have superfluous people participating. So I don't want to just target them that way. But you also see proportional, you can see that some of the delegates, some countries that have very small either GDPs or country size also send a lot of delegates. So we have some small island states that are sending a lot of delegates, even though they don't have very large populations. Right? And so what influences the interests and the way in which the AGN participates, right? We identified several variables through interviews and through some of the statistical analysis. The first is geography. Africa has such a diverse geography, from coastal countries to landlocked countries to just mountainous. They all have very different types of geographies, which just have different interests, and several island states as well. The next, though, that's also related is the economy size. So some OPEC countries are also part of African, the AGN, in addition to countries that are quite rich, like Kenya or South Africa, in relation to very, very poor countries. And so across those divides, you see negotiations that have to bridge quite large gaps in their interests. Right? And we often heard small, very poor countries saying, well, South Africa pretends they're poor, but they're not really poor. Right? And then other countries would say, well, we need South Africa's negotiating power because they have the best diplomats. Language was also a large influence. I mean, some countries speak English as their native language, that was not a problem, but there are French speakers, Portuguese speakers, and those often had difficulty participating in negotiations and had other side ways of participating. So they had WhatsApp chats that would help with translation, or there are other groups that had translators that would go with them. And last is about capacity and preparedness. There are some countries that just don't have experts in every policy area. And so if you only have a delegation of 5 people, it's very hard to send someone to every single meeting who's an expert on it, right? And so there were times when some negotiations that we're having didn't have any African representatives there. So we can see also over time the amount of submissions that the AGN does to COP. It doesn't really have a rhyme or rhythm. It goes up over time. From our interviews, it was about the sort of experts who were very proactive, and once those experts left many of the lead negotiating spots, they didn't submit as many. So there's something about the knowledge, institutional knowledge, that was lost several times throughout the process. And then if you look at the African delegations versus the EU obviously at the beginning is participating a lot. Whereas by the end, Africa is participating almost as much as the EU, right? So there becomes some sort of parity. I don't think, and along with my other researchers, Victoria Markowitz, who was a CCI fellow, and Praise Ganda, who is a researcher in Zimbabwe, our research doesn't point to every increase in capacity leads to wins at the international level, right? They're set within a global context of inequality that Cindy pointed out, in which rich countries still have a lot more influence, and having more delegates or more expertise or more participation doesn't mean that there's going to be able to flip the script right away. In fact, even just having the win of the loss and damage fund didn't mean that they won on the principle of equity or compensation, right? They did have a loss and damage fund, but they didn't get the detail of it the way that they might. And that might have been because they were out negotiated in the end. So looking forward to the next conference, which is this November. The AGN has some big things. We can expect more participation. I expect bigger and bigger delegations. We also expect much more focus on the loss and damage fund, articulating sort of the priorities and who's going to get the funding. And I have also heard from delegates that one of the themes for this next conference is gender, and there are some very controversial opinions coming out of the African delegations about how to conceptualize gender as sort of a conservative way of thinking about gender. So see that as a contentious debate on the horizon. So with that, I'm going to hand it over to Cindy to wrap up.
So one of the things that we want to really emphasize, I think a lot of people are interested in the process and they see how incredibly slowly it's moving relative to the urgency of the problem. And Nick and I, in studying international climate governance, one thing that's really important to remember is that this is an institution that works based on kind of a consensus debate. It only takes one party to bracket a piece of text and prevent it from going forward. So I guess one thing that I would say is that we are making progress, but it is incredibly slow. And so much of it is dependent on this idea of trust and equity, which is what Nick and I both point out in our work, just the importance of that equity. And that's it. And we did take time for questions. So. Okay, and I just did want to say a huge thank you to the Dan and Betty Churchill Exploration Fund, the CCI, Maine Law, and to the SPIA, School of Policy and International Affairs, for helping to support the delegations and our students. All right, so anybody have questions? Yeah.
I'm really intrigued by the different ways that nation states are organizing themselves here. It seems that there's geographic or regional organizations or economic organizations, or like with SIDS, like organizations based on a specific kind of vulnerability. And I'm wondering if you see or foresee in the future like changes in the ways that these sort of like sub blocks are organized, or have thoughts on like which are more effective than others. I know like the Maldives and the SIDS group has gotten a lot of media attention, but yeah, I'm curious your thoughts on that.
At least my research, I think the SIDS group is they're extremely good at media work, right? I mean, if you'll remember the image of the Maldives prime minister in water up to his knees giving a press conference, right? Many SIDS presidents, they were actively doing these types of very big media stunts, but that helps them punch way above their weight, right?
Small island developing states.
Thank you. Yeah. Small island developing states, which is around the world, not just, and they are obviously concerned about sea level rise. The African group is, I think, growing and has much more influence, in part because there's interest in capacity building, and there are several big initiatives from the UN, from the European Union, to help fund the development of negotiator skills, about their knowledge. But that also comes with biases about what kind of things should be prioritized at a negotiation. So if you're learning your capacity from a European Union negotiator, you now negotiate on the priorities of the EU or the African state. So there are some tensions in that. I also think that politics outside of the climate regime impact the way in which those negotiating groups are there. So we have the big ones in the room, the Russia invasion of Ukraine and the Israel war in Gaza, influence how states cooperate even within the climate regime. Right, so Russia was blocking, it's still maybe blocking the use of Azerbaijan as the host. We'll see if it will be hosted there this next year. That politics influences the climate regime.
And there's some people who study that, actually, your question exactly. So there have been some interesting papers about the breakdown of the Arab group, with some pretty significant disagreements between Saudi Arabia and where were we just? UAE, sorry. And also in AOSIS, which stands for Alliance of something Small Island States. Yeah, the Trinidad and Tobago, which actually is an oil producer, and some of their negotiations with other AOSIS groups. So there are fractures, and they do shift. Some countries leave negotiating blocks entirely.
The other thing to note is that many African states are part of the LDC group, low developing countries, and the G77, and so they double dip in several groups to up their negotiating power, to like draw on other capacity that other groups would have as well, which is an interesting strategy.
Okay. So when we're talking about development, I know a concept that's come up a lot recently, especially with the new World in Data drop, is the idea of decoupling, of increasing GDP while decreasing carbon emissions. And that, I mean, we're seeing it for the first time in history that it's possible. Do you think that that will impact or influence developing countries' negotiating stances? Because I know equity is a big concern for them, because if we all just uniformly decrease, then that will severely hamper their ability to develop. If development can be decoupled from carbon emissions, would that more liberal stance as opposed to the equity stance be more I guess attractive to developing nations, or how would that influence, do you think, the trajectory of these negotiations?
There's so much to do. My if I take that?
Please,
There's so much to unpack there.
Yeah, sorry.
So the concept of decoupling, this kind of eco-modernist idea, right, that we through transition to technological improvements and transition to service-based economies, essentially the idea of leapfrogging, right, in developing nation context. The problem is that like the evidence we have is for what we would call relative decoupling. So the growth rate happens at this rate and the environmental degradation happens at a slower rate, but we still get environmental degradation. We don't have good evidence for what we would call absolute decoupling. And I think most developing nations know that now, but they need developmental assistance. So yes, would they be interested in means of implementation support? Yes. Would they be interested in technological capacity building? Yes. Would they be interested in adaptation fund finance? Yes. And that's the big problem. That is the #1 crux of the entire problem of this whole regime right now, is that we are not seeing a willingness from the developed countries to do any sort of wealth transfer.
The
Right?
scale of funding is just minuscule.
Yeah, and so, but really that's what the developing countries are asking for, is that we are willing to make these mitigation commitments. We are willing to do all this stuff, but we need the assistance to do it. Otherwise, you're condemning us to perpetuity and underdevelopment and poverty. So, Bonnie?
Yeah, can you tell me how Indigenous peoples fit within the delegate structure?
Oh, that's a great question. Do you want to take it?
So I'll start with the African groups. There's a specific several observer groups for different types of African indigenous groups from around the continent, right? They don't have any formal participation in the negotiation. They're observers, just like we would be observers. But some national governments take indigenous groups with them as part of the party badges. So at least with the African groups, there are some representatives in that way. I will say it's very small numbers, at least with the African delegation. Do you want to say with the wider delegation?
Yeah, well, one thing that I would say, I'm sure you already know about this, Bonnie, but I can't remember what COP it was, but there was a huge win in Bonn, so that would have probably been COP23, with the establishment of the local and Indigenous peoples platform, which is still in development, and things are moving forward at a slow pace, but did get some representation specifically for the interests of local and Indigenous people. I'm not super up to date on what's happening there. Jamie Haberkamp's following it really closely, one of our old students. But on a more informal level, I can clearly say that Indigenous people are in many ways leading kind of the civil society part of the COPs, and some of the most effective demonstrations that happen in front of the parties that block what's happening and really get people's attention are coming from these frontline communities that are showing up there and sharing their stories about what's happening in their communities. And if any of you guys watched the opening ceremonies of a lot of these COPs, like the camera will pan around when an Indigenous person talks, and because it's so touching, and there will be heads of state who are like crying. So it's I think that there's a real strong effect. Is it as institutionalized as it should be? No. Is there a standing seat at the table for sovereign peoples that aren't represented by their governments? No, and that there needs to be more work there for sure. Yeah.
Time for one more question.
I'm wondering if there are any, just broadly speaking, barriers of entry to the conference itself, with any participating delegates. Like you mentioned, the increasing number of delegates for the African nation, but specifically from like smaller countries with perhaps, or countries with less money to give to sending people around the world. Is there anything like within the UN that provides assistance funding to like reduce that barrier so that people have representation?
Okay, so huge barriers. There is no universal platform that everyone gets 2 people, right? It's about the countries being able to send the participants. There are like scholarship funds to help pay for some countries to come. The UNEP, which is UN Environmental Program, does help each country develop their nationally determined contributions and their national adaptation plans. So that's like a form of capacity building to help them participate. But when they get to COP, oftentimes they have no orientation about it. So there are many training sessions, sometimes through the UN, sometimes through these civil society organizations that are like, so you're a negotiator, here's what you do, right? And I have downloaded and shared with our students who go the handbooks that they're given to these like new negotiators to help them understand what it is. Because many people maybe not have a full background in international law to know like what kind of words have legally binding effect. Many don't have the environmental science to know what exactly is happening. So there's many barriers that way. I will say many states are creative in how to overcome those barriers. So drawing on these different groups, the African Group of Negotiators, the G77, or like informally WhatsApp groups of people sharing knowledge, which is a huge part of it. Yeah.
I would just say you need a glossary because the entire thing is spoken in acronyms and it's super annoying.
You might not even find the rooms because part of the rooms part is hard too. You often see some delegates running down the room like, I'm late for my meeting.
I actually helped a contingent of Indigenous people that were looking for a meeting, and there are these TVs that are scrolling constantly and things are always changing, and they were in the wrong hall and were supposed to speak in like 5 minutes. So I just said, watch my stuff, and I ran with them to get them where they were just in a completely different building. Yeah, it's so hard to navigate. Well, thank you, everybody.
Thank you.
Plug, apply for the humane delegation. If you need information, the deadline is April 15th.
Okay, so we just have one more important event before the cash bar and the posters, which I know you're all looking forward to. And that is the presentation of the 2024 Jacobson CCI Service Award. How many of you were at the 50th anniversary when we gave out the first award? I like to take polls of people. How many have heard of it? How many know that we have the Jacobson Award? How many know George Jacobson? How many know George? Everybody. So it's my great pleasure to introduce George. He didn't know when he received the award, and perhaps this award your assistant doesn't know until about a minute from now, that one of the duties that comes with receiving the award is chairing the next year's selection committee. And George chaired the committee this year. It was composed of 3 outstanding graduate students. George is going to introduce them, and then they're going to take care of giving out the award.
Well, thank you all. Thank you, Dan. Well, I was immensely surprised when I received the award about 18 months ago. I had no idea that was on the agenda that time, and I kind of forgot about it until a couple months ago when Dan informed me I was chairing the committee to choose the next awardee, and which turned out to be a great honor and a very enjoyable activity to do. There were 3 students chosen, I believe, by Dan and Paul, is that right? Who represented graduate students in the Institute. And the idea then and looking forward, we hope, is that we can represent the 3 different components of the Institute back at the beginning in 1972 when we were the Institute for Quaternary Studies. And we have an anthropology archaeology group, we have a geology group, that glacial geology, glaciology, and that sort of thing. And we have a biology group. And they're all represented in the Institute today. We heard talks about all those things today. And it's wonderful. Well, the 3 students were chosen not only to represent those fields, but to represent the strength of our graduate program and as examples of the strength of our graduate program, because there are many other grad students who will in the future have a chance to do the same thing. And the 3 were Maddie Landrum, Elizabeth Leclerc, and Xander Roman. And I'll ask them to come up here in a moment. But it was a very interesting process because now none of us had any idea what we were going to do or so forth. But it became obvious at the beginning that several things had to be done first. Number 1, develop some criteria that could be passed on from year to year that would allow good candidates to be identified each year. And then Second, to develop a process, a procedure that could be followed so that candidates could be identified and one finally selected by the students only to present the award. And we talked at the end, I was in on some conversations, and we talked about the fact that there are so many good candidates to choose from within the faculty and staff of the Institute, and we agreed that in any case, no matter who is that year's awardee, the others are not losers. They're only just waiting their turn. And that we're very serious about it. But anyway, we do have an awardee for this year, and I would ask the three students to come up and make the award.
So as George said, this was an incredibly difficult decision for this year because there were so many faculty who made our list. We have maybe the next 2 decades for other awardees. So I'll start by reading off some of our award criteria that we came up with during this process before we name our winner and go through all of the amazing accomplishments that they have had during their career. So the Jacobson Service Award recognizes faculty and staff of the Climate Change Institute who have, over the course of their careers, performed an outstanding service above and beyond their professional duties to the Institute and the university, often having a local, regional, or even global impact. Nominees are recommended and evaluated by a committee of 3 CCI students with historical perspectives on the previous year's recipient of the award. Nominees are evaluated by the magnitude of their impact, the value of their service to CCI and beyond, the extent to which that service has gone above and beyond their career professional accomplishments, and to the length of their service to CCI. Thank you, Maddie. This year, the award committee recognizes Ivan Fernandez, professor of soil science in the School of Forest Resources and cooperating professor in the Climate Change Institute. Ivan was instrumental in the unfunded development and publication of the Maine's Climate Future Reports, published in 2009, 2015, and 2020. These reports effectively communicated the realities and implications of climate change for the state of Maine. The 2020 report also provided the scientific foundation for the Maine Climate Council Report and Action Plan, Maine Won't Wait. In addition, Ivan worked for nearly a decade to launch the Maine Climate Science Information Exchange, which establishes valuable connections between climate-related scholarship at UMaine and the development of public policy. And for these and many other examples of service, Ivan Fernandez is an outstanding role model for scholars in CCI.
I'm dumbfounded. Thank you for this honor. I don't have a speech today. It's a privilege to be part of this institute. We've got scientific rock stars. We've got I'm very pleased to know, since I understand how the system works, that we've got several decades already selected of awardees. It's incredibly impactful to be able to say you're from the Climate Change Institute because of the work that all of you do, and you're all part of the Institute. You know what you see every day around you, and the kind of impact that science has. And obviously it's never been more meaningful than it is now. So it's a privilege to be able to do that kind of work. To have colleagues like all of you, including students, staff, and faculty. I'm overwhelmed with appreciation. It's a particular honor to award of a close friend, colleague, and namesake, and role model, George Jacobson. I know I'm between you and the cash bar. Thank you very much.